Hello and welcome to another Friday edition of the Coding Train with me and some new cloaking device for this laptop over here. This is why I'm late actually. I was up here leisurely, just like getting some fresh green paper with some tape and making nice little things of tape and putting it on the green paper and then putting it over here. You're wondering what I'm talking about. You can't see. Maybe I could go here. No, that doesn't really help. So anyway, but then I realized, oh, it's 1:30. I have to start live streaming. So people in the chat are pointing out that something is different. Let's see. Can you figure out what is different? And no, I'm not referring to my haircut, although I did get a haircut. This is less than 24 hours old. No Wilderness Dan, unfortunately, today. There was a very strong Wilderness Dan vibe yesterday afternoon, and I decided to get the haircut because there is also something else different. I'm looking in the chat. The snow is gone. It is a balmy 60-some degrees Fahrenheit here in New York City today. It is a warm, almost one might say spring-like day, and I decided that today is the day that I will remove the Coding Train's snowy background. All right, so here I am, as I often am. Let's say you're watching for the first time. Maybe you are, maybe you aren't. It's very unlikely that you are, but let's say you are watching for the first time. My name is Daniel Schiffman, and I appear every Friday, except for some Fridays, including, unfortunately, next Friday. Next Friday will not be here next Friday. I'll try to have a makeup date for that. But every Friday to do some coding tutorials, some fun time, coding time things. Generally feel weird about the whole thing. I'm actually just in a closet on the 9th floor of the 720 Tisch School of the Arts in New York City. There's no windows in here. I'm by myself. I've got some lights on me and I'm staring at a camera lens. But I have this sense that there are people out there watching and that they're interested for some strange reason. And what I have, not really what I have to say, but perhaps what I am going to do. So let me take a look here. And I'm just checking the chat. Gray Wizard got no snow in the chat. I don't know if that message came before I said it or not, because the timing is hard for me to tell, but I'm going to assume that Gray Wizard did figure it out. So I'm excited. I know I appear a little bit subdued today. I'm not sure why. I didn't plan for that. It's just sort of what's coming off of me here. But I am going to do something that I've been hoping to do for a long time. I'm going to tackle, do I have it open? Neuroevolution. So let me show this to you. This here is a version of the game Flappy Bird, otherwise known as Flappy Train. This is a version that started with what is in this GitHub repository, the Coding Train Flappy Bird clone. This is a fork of that repository made by Versatilis, a Coding Train contributor. Did I pronounce that? I actually don't know. That must mean something. We're on generation 7 here. Oh, I was wondering why I'm only on generation 7 when I was letting this run in the background because I didn't have it open. So I have a bunch of examples of something called neuroevolution, meaning a genetic algorithm to evolve a neural network for some tasks, such as an optimal play strategy for the game Flappy Bird. And so I'm going to, as coding challenge number 100, I am going to make my own version of, look at that beautiful, oh, almost made it. Make my own version of this. Let's see if, though, before I do that, I can get some thumbnails for Mathieu. We need some pipe designs to come in here. All right. All right. So that we need to have a good thumbnail for the video that's going to come out. That was me during the live stream posing for a thumbnail image later. That's exactly what you were watching. So what I'm going to do today is I'm going to make a version that does precisely this, that evolves an optimal play strategy for the game Flappy Bird. I, however, even though I did say that the reason I was making this particular GitHub repository was so that I could have a more fun, interesting coding train themed design for the game. This became enough of a project that the complexity of the code is such that I would rather go back to my original simplified, it's just an ellipse and white squares, white rectangles as the pipes design for Flappy Bird in order to just demonstrate the core aspect. So in the tutorial, I'm going to use just, so let me find that right now. So I'm going to go to, by the way, did you know that the Coding Train has a website? It is thecodingtrain.com. Oh, weirdly, I thought it's supposed to say like live, like when I'm live here, but I don't know why it doesn't do that. Maybe it doesn't do that. Who knows? At this website, you can find things like a button to subscribe to the Coding Train channel. If you have not subscribed, maybe you might like to subscribe. I'm supposed to ask you that because that's the number that is like the thing that means something. But should it mean something? I'm not so sure. Who cares? All right, then you can also, if you so choose, become a patron through the service Patreon, and you will get an invitation to a Slack channel. And in the Slack channel right now, Don Wilson asks, is the level generation the same every loop, or does it change each time? There's my simple version of the Flappy Bird game has no no concept of levels. It's one game that just happens. Now, let's say I wanted to find my original code for that Flappy Bird game. I'm going to go here to Coding Challenges. Then I'm going to search on this page. I'm going to go to Flappy Bird, and here we go. Oh, Flappy Bird. So here it is. Coding Challenge. It was number 31. I wore, let me see, do I still have that green headband? Hold on a second. Indulge me here. Oh, I do. In that Coding Challenge, I thought it would be fun to have like a rainbow headband for like I'm a 1980s aerobics instructor doing coding. But the problem with this headband, as you will soon see, is it might just look like it has like if I stand over here, it looks like it just has like a white stripe, but it's green, and you will notice that as soon as I go over here, and you will see it changes color, or I walk around, you can start to see the text through it. So I don't think I can wear this because too many people make the comment that your head is separated from your body, but there we are. Okay, so now, if I'm on the Coding Train website, I could next click, I could watch that video, or I could go to the challenge, and now I am on a web page that has the name of the challenge. It has a description here. In this coding challenge, I attempt to program in JavaScript using the p5.js framework. Probably should say p5.js library right here. A clone of the game Flappy Bird. And then I could click here, get the code, and it's downloaded for me. I could also click here on Live Example, and I could see here is the game running in the browser. What is the deal? What's the deal with slow frame rates in the browser? Have you ever, poor Seinfeld impression. Why is this, like what's going on this computer? It says 30 frames per second. I just feel like when I was looking at this on my other computer downstairs earlier today, it was very, very fast. I got to make some improvements to this game. So, okay, what am I here for? I am going to grab this code. So bear with me for a second here. I am going to put it on the desktop, and I'm going to rename it to Neuroevolution Flappy Train. And I am going to open this up in the Atom. Maybe I'll use, Noopcat, excuse me, NoOpCat was here last week. I've not released the edited version of her tutorial, but she installed iTerm. Oh, a tip of the day message, yeah. Ooh. The window shows iTerm 2 tip of the day. It will appear every 24 hours to let you know about new features and hidden secrets. More options to view, more tips. I would love to just stay here and look at all these tips, but I gotta get moving. I'm on a time crunch here. 4 p.m. This challenge will be over. the live stream will not be over, but the challenge will be over. All right, I'm not ready for a new workflow today. I was gonna use Visual Studio Code and iTerm. I'm not ready. So close to being ready, but I'm just not ready. So I'm gonna go to the desktop. I'm going to go into this sketch, and I'm gonna run my fancy little simple HTTP server. I'm gonna minimize the terminal. Then I am going to open the Atom editor. Right? These are the things that anyone else would do before they start live streaming, but I cannot bring myself to do that. I'm going to close this. I'm going to go here. I'm going to drag this down to the Atom editor. I'm going to narrate everything I'm doing on the computer so that you can hear what I'm saying. And then I'm going to take a look at the code, and I'm going to indulge whatever it's asking me to do here. All right. So, hello. Are you still watching this live stream? I was quickly just getting my code from Coding Challenge 31 because that is the base code I'm going to start with. I'm getting a notification. Ah! Oh, there's a meeting I'm supposed to go to. I would have missed that meeting today. It's okay. I'm going to miss that meeting. Everything's fine. Calendar alert, go away. All right, so now what I want to do, a few things I want to do. I want to go into the web browser. Here is the game. I know the camera has shut off. I really was starting this afternoon because I thought I'd have a little more time this morning to like prepare some stuff and maybe try installing Magic Lantern firmware. I didn't get to it though. Surprise, surprise. Okay, so I need to do some stuff to the game first. So a couple things I want to do. Number one is I would like to be using the most recent p5.js, and I'm just going to reference it from the CDN. So I want p5min.js, which I'm going to put here. And then I might want to use the DOM library. So why don't I get this? I'm going to use the minified versions. Oh, okay. Notifications are coming in. Correct. Simon in the chat says, I thought you've done this as Chapter 11 of Nature of Code. That is correct. This coding challenge will be part of Chapter 11 of the Nature of Code book. The new Chapter 11, to be written. All right, let's make sure this still works. And now. Nothing's going to happen. I just felt like doing that drum roll. Now, okay, let me move a little quicker here. I lost what I was thinking about. Let me replace var with let. Now, I'm going to show you guys a fun little tip. Here is a nice little regular expression for converting something from ES5. Is this, what's going on here? Oh, it's the table is just poking through there. Converting ES5 constructor function syntax to ES6 classes. And I'm going to say find, and I'm going to look for, I'm going to turn on regular expressions. I'm going to say this /dot, parentheses, dot, star, question mark, end parentheses, space equals, function. See this? Look, I want a regular expression that can find every single reference to this dot, a function name equals function, parentheses. And I probably should make the amount of spaces here optional. Oh, no, come back. Oh, it went away. Huh? What the? I have to retype that in. Well, I will zoom into it at least now. So you'll see. So I'm making a regular expression here. I am looking for this. The reason why I put /dot is because I want to escape the period. The period as a meta character in a regular expression means any character. Then I want to capture whatever is in here. I don't want it to be greedy, like I want to stop as soon as I match any number of spaces, followed by an equal sign, followed by 0 more spaces, followed by the word function. So now that I have done that, I want to replace this with just what I captured there. So I want to turn this constructor function into an ES6 class. And so now I'm going to say replace all. And I have done that there. I'm going to do it on the pipe. I'm going to say replace all. I have also done it there. Now I'm going to go to and I'm going to just start doing this manually now. I could make a regular expression for the rest of it, but it's only 2 classes. I'm going to change this to be a constructor function. And I'm going to go to the pipe. And I'm going to change this to be, oh, whoops. I have to change this to class. That's what I meant to say. And then on the pipe, I'm going to change this to class. And then I'm going to write a constructor function. And I'm going to close it here. And there we go. So now I have, hopefully still, a working game. All right, let me fix up this game to make it a little bit better. Number 1, let's change the resolution to like 640 by 480. Oh. Okay. Why is it so weirdly, what is going on? Why is it running like it's the slowest thing in the world? What is am I crazy? I'm looking for like, did anybody follow along running this code and it's running like this sluggishly? Is it because I'm sending the output of the, I'm so confused. All right, let me not worry about it. I'm going to make the pipes a little bit wider. They look very thin. That looks better. I am also going to, I think this is, let me go to, let me get this improvement from, that's already in. So I think this is better to actually have the same spacing between each pipe and then a random spot where that occurs. So let me do this. Let me grab this. And let's see if this works. No. No, it didn't work. Okay, why didn't that work? Let's look. Let's take some more improvements from here. See, this is why I didn't want to get into this. Draw half, draw half. Oh, I can't deal with this, I can't deal with this. Rect mode, this.x 0, this.w, this.top. This.x height minus this.bottom, this.w, this.bottom. That makes sense. Does this make sense? The top is a random place between a random place between height divided by 6 and 3/4 of the height. That sort of makes sense. And is there some like, let me just make sure, rect mode corner. So what have I done here? Let's say pipes index 0. Spacing is 125. The top is 267 and the bottom is 392. And the x is 210. This makes sense. Top, spacing, Oh, this is going well so far, isn't it? Let's comment out that. Top is 124. That looks like about 124. The second one, top is 248. That looks like it. So that looks like that's right. So the bottom is this dot top plus, oh, that's not the side, that's, aha. The bottom is the location of the bottom. This is easy. But I probably should conform to whatever I'm doing here, which is the way that I'm height minus. So the bottom should actually be height minus this dot top plus this dot spacing. Right? The way that I have programmed this is that I want the bottom to be the y location of the bottom, but the way the way that I actually have programmed this is for the bottom to be the size of the bottom, right? Because the way that I'm drawing it is from the height minus that much. So it's not the location, it's the size of it, which should be fine. There we go. So there's always going to be, why is it so slow? It's always going to be 125. And boy, they're really quite... Using the original code, I get 60 frames per second. Yeah, right? What's going on this computer? Something's going on with my Chrome. I noticed that this computer was having this issue. Well, that's the same speed. Does that feel faster to you? How do I see the, how do I find the console, web developer, web console, frame rate? Weird. Is it actually? All right, so hold on. Wow, I'm getting like 20 frames per second. Too many pages open. I don't think that's the problem. I do have this open. That certainly can't be helping. But look at that. It's like so sluggish. All right, I got to figure this out. Everybody, I'm going to do something kind of terrible. Let me, I will remove this later. If you all could do me a favor, and I'm just uploading these files. Run this, please. There is now in the Flappy Bird clone GitHub repo. This will just take a minute here. Try this sketch and let me know if you're getting the same speeds as I am. Because I don't know why it is running so sluggishly. Which is fine, like I can live with that. Like I can always okay. Like for example, I can make the pipes faster, and I can have the pipes come out less often. Like, so, but it's just like barely running. And yeah, right, 60, like something's going on this computer. And yeah, why? I would restart the computer. I don't want to do that. Yeah, people are getting 60 frames per second, right? I guess I'll try restarting Chrome. I have an idea. I'm gonna take extreme measures. I'm going to clear, hold on. Wow. No, but once the page has been served, Like all my momentum has been killed. All right, fine. Let me look at this. Well. Let's try. Let's look at Firefox. Frame. Well, I guess I don't really care that much. 30 frames per second. Yeah. I'm still only getting 30 frames per second on Firefox. Maybe I'll restart this. I'm just gonna restart the computer. I don't have to restart the stream. And then I'm going to give up because I don't want to spend all my time. I want to get to the coding. I lost all of my energy. Let me restart I did just restart the computer. I'm in the void. Oh. Try to enable hardware acceleration. What's that? Try disabling the friendly errors, but that shouldn't be enabled. So let's check some stuff. And then what I just need is probably a new computer. Let me do Chrome is up to date. Okay. Yeah. Sluggishly sluggish. Disable friendly errors. Did I spell that right? Disable friendly errors. Oh, equals true. Equals true probably would help. Weird. Okay, enabling hardware acceleration. How do I do that? Preferences. Yeah, it's enabled. What if I disable it? Oh, I feel like that got better. Well, Fascinating. Yeah, it's worse. Hi, Giannis or Jonas? All right. That's it. I'm out of here. Train is leaving the station. This doesn't make any sense. I think it's just this. I think it's just time for a new laptop. I think this laptop just has a lot of trouble. Really, it's on its last legs. Probably should do something to help it out. Oh my God, look at that. I'm going to all right, I'm going to live with this speed. It's perfectly fine. It's 30, I'm not really leaving. It's 30 frames per second. I turned off the hardware acceleration. So the reason why I don't think this matters is I'm pretty sure that's why I was using the minified version of P5. The friendly errors are disabled by default, I thought, with the minified version. Why are the pipes never arriving? Do this. This should be easy enough for an agent, an AI agent to beat. It's pretty easy for me to play. I'm just testing out the game here. All right, great. Let's make the pipes a little bit closer. Just don't want it to be too easy. I think this is fine. Let's make the pipes speed a little bit faster. And that's good. Okay. All right. Okay. Everybody, now we're good. We've got this game. I don't actually need this highlighting thing, so I'm going to take that out. That is not relevant for this particular thing that I'm going to do. The other piece, however, that I do need is I need the files from the toy neural network library. I need to have matrix.js and neural network.js. And I just need to put those in here. I'm going to put these in live. I'm not actually using this anymore. And right, I'm referring to 0. I have actually a weird sort of nonsensical theory that I'm going to try in a second. And then I just need to reference those files as well. Matrix.js, okay. All right, now we're cooking. Now we are cooking. Okay, so hold on, everyone. There's a couple of one thing I'm just curious to try. Oh, those are in, sorry, a folder called libraries. I think it's fine. I just thought maybe I'm going to live happily with my 30 frames. I feel like my browser must be like, oops, no, whoops. I'm just not going to worry about this anymore. I'm sorry. We're going to do neuroevolution. Okay. And this one over. Whoops. There we go. All right. All right, everyone. I think it has something to do with the integrated graphics, probably. Yeah, all right, all right. Let me check some of these smart ideas. Whoops. Nope. It's locking me at like 30 for some reason, even if I don't do anything in draw. This is a really old Mac. I do need to get a new one. Yeah, I also have this suspicion that, hold on a sec. Give me one more thing to try. I have now unplugged. This is the plug that goes into the laptop so that you can see what's on my screen. Watch, here we go. Can you read my mind? You must be able to read my thoughts now or see them. Are they displayed behind me? I hear computers can read minds now. No, it's not working? All right, hold on. Just give me a second here. Oh, look at that. I'm a dummy doofus dummy. I'm getting like 60 frames per second, wildly fast now. Really? Just the output causes the browser to not be able to render all this time? It's been this cable? Yeah. The HDMI out is set to 30 frames per second. It is true. Hold on. Sometimes it's the little things in life. I know I never get anything done, but just be with me here in the moment as I try to achieve 60 frames per second in the browser. It's totally the screen refresh rate, which, by the way, I think I have hacked. No, it went back. So let me go to the display preferences. And okay, so now, oh, you can't see it anymore. But so I just switched it to 1080i. Hold on, everybody. I think we're going to be good in a second. All this time. No. Oh, come on, up here. It won't show up at 60 frames per second. That's so sad. It won't let me output it at 60 frames per second. Well, what if I do this? No. NTSC, no. 1080i 60. No. 1080i 50. Oh, weird. This works, but there's some weird stuff going on. Is this a problem? Yeah, 30 is totally fine, especially now that I know what the issue is. But I just like it like this. But does this look crazy weird? I might need a better HDMI cable for 60. I just, like on my preview, it looks all distorted and weird, but I can't tell. No, I know I could just double the speed of everything. Just run 720p. Gross, it looks awful. Okay, we're going back. We know what it is. Refresh rate is at oh, look at this. Now I have this option. Hold on. Didn't give that to me before. Oh, because I was here. Hold on. I was at 50. Oh, it looks even worse. Okay. We don't want I. I is bad. We want, give me my scaled. I want, 1080p. And then 30. And 30 is the maximum. All right, going back to 1080p 30. Oh boy. We're going back to 1080p 30. And There we go. Is there an option to disable the vsync in Chrome? That is an interesting question. Whoa. Also, what happened to my Chrome? There we go. So now we're back. We've got 30. And now Chrome settings, let's see. vsync. No. 1600 by 900. Well, now we know a little bit more about interlacing. We're fine, everybody. I'm done with this nonsense. I am moving on. This is the version of Flappy Bird. The pipes look... I think I want to just make the bird's motion a little bit, like the gravity should be like a little bit stronger. And, it's got this like dampening, which I think is kind of unnecessary. Ooh. Yes, I know what's happening here. And, okay. Ooh, that's way too much. All right, a little bit hard to play here. That's better. Just want to make sure the game, I want to make sure like I can play the game, and now I'm able to do that. Okay, great. All right. Chrome flags vsync. Is that really a thing? There's no vsync in Chrome. Okay. All right, everybody. Let's get to some coding, huh? Let's get to some coding. Before I can get to coding, I must get to erasing. Goodbye to no-op cat's drawings from last week. You would think that these would get erased sometime in between when we finished last week and now, but no, it was not meant to be. I basically run out of this room as fast as I can as soon as I'm done and do not return to it until a week later. And I have now exactly 1 hour, 1.5 hours to complete this coding challenge, because we are not going to spend any more time worrying about the vsync. We are just going to get to coding. Okay, good. Here we go. All right. Let's check this pen. Pretty good. Not so great. Let's try another one. You can't see what I'm drawing because I'm drawing above. Better. Better. Ooh, no good. Trash. These ones over here are probably trash. All right. Now. All right, gotta let this run for a little bit. Negative 8.5 is the highest with 0.6 gravity. I think I like where I've got it right now. I'm gonna let this one run from, how do you say versatilis? Versatilis, is that the correct pronunciation? So I'm going to let this one run because I want to start the opening of the coding challenge with nicely. Oh, I really should. So we'll give this a few more minutes. I should have been doing this. I realize I can't let it run in the background because if I go here, though, is it still running? Yeah, as long as it's like. So I have the neural network libraries. Let me just remember a couple things I want to find. Let me just remember, does this have the copy? Yeah, it has the copy function and it also has this, mutate function, which, this is weird. I'm going to change it. Yeah, let me leave it at like, change it to this. Okay, we have that. You know, I was thinking actually, anyway, so let me make sure this is there. Then the other thing I want to go to is the pool selection, closed. Yeah. This particular, I want to make sure I have access to this algorithm, and I think I actually have it in the traveling sales person coding challenge, TSP. I just want to have this. Yeah, it's this function. Great. Great. Okay, I just need this function. Okay. All right. Okay, Eric says I can use his real name. This is from Eric, coding train contributor, Versatilis on GitHub, who has been helping me manage some of the code in the neural network library. He made a version sort of testing how the neuroevolution stuff would work, and here we go. Looks like after a little bit of time, it got almost all the way there. Okay. While I'm here, let's do that. Let's do a little moderation. Just here moderating the YouTube chat for a minute. Okay. And now we're ready. Let me all right. Okay. It's time for coding challenge number 100. Here we go. In this coding challenge, I am going to do something that I have been wanting to do on this channel for, I don't know, about 100 coding challenges. I'm going to make a project that involves neuroevolution. I am going to combine both neural networks and genetic algorithms into an agent, into a simulation of a simple game, and I'm going to train that agent to play that game effectively by making decisions with a neural network and evolving its neural network with a genetic algorithm. Way too much explanation. So this is a demonstration that Versatilis on GitHub, coding train contributor, Eric made. This is using the Flappy Bird clone GitHub repository that various folks have contributed design ideas to, and is actually running Neuroevolution right now. And you can see these trains are kind of getting better and better at making their way through these little gaps. So I'm going to program this myself. Now I'm going to make a version of this in this coding challenge. The difference, however, is I want to work in a sort of a simpler place. So I am going to use the code from, I think it was coding challenge number 31, which just is this simple version of Flappy Bird that I'm playing with the spacebar right now. So I took out all the design stuff just to see if we can get the, whoa, God, I'm terrible at this, the mechanic of the game working. Now, I need to move over to the whiteboard for a second. Before I can write any code, I want to talk about all of the pieces going on here. All right, so number one, I need to have the Flappy Bird game. So you can look and find, if you wanted to recreate this coding challenge, you can go and get coding challenge number 31. I've actually made a few minor tweaks to it, but I guess after this is over, I'm going to update those. So coding challenge 31 will mirror the code as I start with. Then I also need the toy neural network library, which has two files associated with it, matrix.js and also neural, I think it's just called nn.js. So this is the code for the neural network and some code for some matrix multiplication math that's part of the neural network. If you're interested in how this library was made, boy, do I have a lot of tutorials for you. Link to those somewhere in this video's description. And this, by the way, incidentally, just has a file for the main sketch. I believe it has a file called pipe.js and one called, I know I'm probably writing off the side here, but close enough, pipe.js and one called bird.js. Okay, time out for a second. I'm not able to see over there. Okay. So this is all the code that I'm going to start with. Now, nowhere in here is there anything about a genetic algorithm. So most of the code that I'm going to write during this coding challenge, I'm going to put into a new file, and I will call it ga.js. There are a couple features that are in this neural network class that I put there for the purposes of being able to apply a genetic algorithm. And those are a function called copy, which allows me to make a complete copy of a neural network in its current state, as well as mutate, which is a function that allows me to make some minor random changes to the state of that neural network. And when I say state, I mean all of the weights. So these are some things that I'm going to definitely need to make use of. What I will not be doing is I won't be training the neural network in the sort of traditional way that you might have seen in some of my other videos, like the doodle classifier or the XOR challenge, where I'm using this thing called backpropagation, supervised learning. What I want to do in this video is something that's akin to this idea of reinforcement learning. Now, reinforcement learning is a field of research that's been around for a very long time. It predates deep learning, neural networks, all that sort of stuff. And I would love to come do lots more tutorials about reinforcement learning. The recent advances that you might have seen with things like DeepMind, and its bot that learned to beat all of the Atari games. Those were developed with a style of reinforcement learning called deep Q learning, which uses a neural network and trains the neural network based on this reward-based system. So you have this idea of, in reinforcement learning, that you have a world. The world is going to be, in our case, the world of Flappy Bird. The world has a given state. The agent or the entity that is being reinforced, trained, that is learning, based on that state, decides to make an action. I'm going to jump up. I'm going to not jump up. In this case, of Flappy Bird, it's very simple. And then based on that, there is a reward. That reward is fed back into the system, and we kind of repeat here. Now, here's the thing. This is what makes deep reinforcement learning and other reinforcement learning scenarios very complicated. Let's just think about this in the case of Flappy Bird. I am a bird, I am over here. This is the state. The state could just be the pixels of the display, and that's in fact what was used in this in the DeepMind project. I Oh, let's rewire my brain. Tick, 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 boop. I am a bird, and I am looking at the state and evaluating the state. I'm going to choose to make an action. That choice is to jump up. I now expect my reward. Please, everybody, shower me with your gifts. I have made this wonderful decision to jump up. The problem is, how do I know if that was a good or bad decision? I don't really right now. I don't until much later. I don't, the payoff for certain things that I might do in a game scenario, how do I know if I'm, what's another example of this? Chess. How do I know if I'm playing, say, the game chess, if this move is really going to be a good move for way down the line? This is something I really need to figure out. It gets very complicated very quickly. The good news is I can use a different system. I can say, you know what? Instead of trying to actually figure out whether it was a good or bad decision, I'm just going to make a whole lot of these birds. Maybe like 1,000 of them. They will all have random neural networks. They will just make random decisions, and maybe some of those random decisions happen to be better than some of the other random decisions. I will then take those into a new generation and repopulate the world with 100 new birds based off of those ones that did well over and over and over again. The same principles of a genetic algorithm. So now I might refer to you, if you have not ever worked with a genetic algorithm before, I'll refer to you to my genetic algorithm tutorial series. Time out for a second. Okay. All right. Everything's fine. I'm having a little inside joke with myself. Okay. All right. Let me just check to see any questions so far. I kind of want to do that again because I took too long. I also want to just quickly, I want to make sure I reference some work that has come before me in this area. So I want to have this link open and available to myself. Okay. All right. Okay. Hold on. Okay, got it. Okay, yes. So Simon in the chat is saying that is not reinforcement learning, that is neuroevolution. Exactly. So what I'm doing in this demonstration is similar to reinforcement learning in that I am using neuroevolution to train an agent to find an optimal strategy to a game, which is exactly what reinforcement learning is often used for. And I am just going to do something here. And there we go. Okay. Moving right along. Thank you, Mathieu, for figuring out to edit all this extra noise stuff out. So let's see, what's next? Okay. Okay, so let's go and write a little bit of code, and then we're going to have to come back here to the whiteboard, I know, in a second. But let's start doing a little bit of code here. So I'm going to go into the code. I'm going to go into the bird class. And right here I'm noticing, okay, this is the function that causes the bird to jump up. How is that currently decided? That is currently decided in sketch.js here when I press a key. This will no longer be the case. This entire function is now going to be commented out. I want the bird to make its own decision whether it should jump up or not. So now I'm going to go over here and I'm going to say this.brain equals new neural network. So the idea here is that inside the bird object will have its own neural network, and its neural network will be the thing that makes the decision whether it should jump or not. I'm remembering. This is not an original idea I have, of course. I will include some links in this video's description to other references and papers on neuroevolution, but I also want to briefly just point out a bunch of these links, which are here. These are some other neuroevolution demonstrations that are on GitHub from various other GitHub users. There's a Flappy learning one, an asteroids learning one, the steering agent, snake neuroevolution, and neuroevolution playing Super Mario. So I'll include links to all these as well as some of these papers and other resources in the video's description. Okay, so now here's the thing. If you watched any of my neural network tutorials, you might remember that what do I need to put in here? I need to say how many inputs, I need to say how many outputs, and I need to say how many hidden nodes. So what goes in there? This is where we have to return to the whiteboard. Okay, so here's the thing. This is the game Flappy Bird. I'm going to now architect my neural network down here. I need a bunch of inputs, I need a bunch of hidden, and I need a bunch of outputs. Let's go with the easy part first. The easy part here is perhaps the outputs. So let's say I wanted to train an agent to play a game that used the arrow keys. So the player of the game can either move up, down, left, or right. There's 4 options. I would have 4 outputs. I want a vector with 4 outputs, each representing the probability or the confidence score of whether the agent should move up, move down, move left, or right. In this case, I don't need 4. The only decision is jump or don't jump. In this case, I really only need 1 output, right? I can have 1 output that ranges between 0 and 1. If it's greater than 0.5, jump. If it's less than 0.5, don't jump. Let's just do that. So let's do that. That's going to make our life so much easier. So I'm just going to have 1 output. Oh, so simple. I'll do some other examples in other videos with more complexity. 1 output. Now, how many inputs? This gets a little harder. Now, wouldn't it be nice if I could write some generic code that's basically going to work for any game? As long as I have a way of evaluating the score of the game, the same code will work for everything. And one way of doing that would actually be the pixels of the game as inputs. So maybe I take the visuals of the game, I sample it down to a lower resolution image, I flatten that into an array, I take the brightness of every pixel, I feed that in as the inputs. That's certainly one thing I could do. I would love to try that as an experiment as a counterpoint to the way I'm going to do it in this video. I'm instead going to take somewhat of a higher level approach, and I'm going to do some feature extraction manually with my brain. I'm going to say that I think, I have an eraser anywhere? That I think that I don't have an eraser anywhere? Ooh, I do have this. Oh, I shouldn't use this headband to erase. That's a bad idea. All right, I have a paper towel. I will use that. I'm going to decide that I think that the important properties, the inputs, should be the y location of the bird, the x location of the closest pipe, the y location of the top pipe, and the y location of the bottom pipe. How many inputs is that? 4. So I'm going to have 1, 2, 3, 4 inputs and 1 output. And I don't really need to have these bracket things here. Okay. So I've decided how many inputs and how many outputs. So now the other question is, how many hidden nodes should I have? To be honest, this isn't a very complicated problem. This might work with just one hidden node. It might work with no hidden layer at all, even in fact. It might work with just two of these inputs and be able to figure it out. But let's just decide that we're also going to use 4, just for the sake of having some hidden nodes. We can experiment. Does it work better if I make 64 hidden, or 4, or 8? Trial and error is your friend in machine learning systems. Okay, so now, this is now the diagram of the neural network. I must sit here and connect all of the various lines. Right, so the inputs come in here, and the output comes in here. 4 inputs, 4 hidden, 1 output. If you want to learn more about how a neural network works, all of the internals that are going on here, what all these connections are in the weights, I'll refer you back to my neural network tutorial series. But this is pretty similar also to what I did in the color predictor. There were 3 inputs and 2 outputs. I can't remember. All right. All right, so now we've decided that I want to have 4 inputs, 4 hidden nodes, and 1 output. So we now have the brain of our bird. And then in update, the bird is going to decide, oh, oh, this is more complicated than I thought. Let's write a new function. Let's write a function called think. So in think, basically what I want to do is I want to say, let the output equal this.brain predict, and I want to send in the inputs. So for example, the inputs have to be an array of 4 numbers. Right? So they would look like something like this. I'm going to put them in there, and then I'm just going to say, and if the output is greater than 0.5, then this dot up. Right? So this is the idea here, that the neural network library that I'm using has a function called predict. When I call that function, I send in the inputs. The inputs go feed through times the weights, summed, activation function, times the weights, summed, activation function. I get the output. And based on that output, if it's greater than 0.5, the bird jumps. If it's less than 0.5, the bird doesn't do anything. But this is no good here, right? This is just me. Let's just see if this works, though. I mean, these are hard-coded inputs that never change. That's not what I want. But let's just at least see if I don't get any errors. So I'm going to, in here now, I'm going to add something. I'm going to say bird.think. And I'm going to run the sketch again. Oop, look at that. It's thinking. It's jumping. Right? It decided, ooh, every time it's basically always going to be up at the top or at the bottom. Right? Because it's getting the same inputs over and over again. Now what I need to do is actually make inputs out of these values. These values. Its y position, top, bottom, and the x position of the pipe. Okay, let's do that. So now I'm going to say, back in the bird, I'm going to say let inputs equal an empty array. I'm going to say inputs 0 is this bird's y position. Inputs 1 is, oh boy. Okay, here's the problem now. I need to know about the pipes. So I am a bird and I need to know about the pipes. How do I do that? So maybe what I'll do is I'll take in as an argument to this function, I will take in the pipes array. So that is sent into the think function. Now I'm going to go here, and I'm going to say, I'm just going to do pipes index 0. This is a bad idea, but let's just start with this. Pipes index 0 top. Inputs 2 equal pipes index 0 bottom. Inputs 3 equal pipes index 0 x, right? So this is the idea here. I want all of those things to be the inputs to the neural network. I don't need this anymore, right? Because I am getting them from the properties of the thing. And now let me run this and see what happens. It's kind of jumping all the time. It's kind of jumping all the time. All right, so this didn't really seem to improve. Ooh, look, ooh, it's doing something. That one actually kind of almost did something. It's making some of its own decisions. That was very exciting. All right, well, I've got some problems here. Number one is, when I sort of made my pretend version of it, I purposely made numbers between 0 and 1. So one thing I should really do is normalize all these values. That's a pretty typical thing to sort of clean your data. So what I'm going to do is I'm going to say this dot y divided by height, this dot top divided by height, and this on the pipe's bottom divided by height, and the pipe's x divided by width. So let's do that. And identify, oops, let's get rid of this now. Nothing really different is going to happen here. I'm going to run this a bunch of times. Oh, it's doing something. Oh my God, it's making some. Ooh, that was a good one, right? That was a pretty good one. All right, so you can see that it's doing something. It's trying to think. But I've got another problem. I don't know, is pipes 0 the right pipe? I think I probably need an algorithm to check which pipe is actually the one closest. Let me look at the main sketch. How do I add the pipes? Yeah, so first of all, the pipes are getting added to the end. And if the pipe goes off screen, it gets deleted from its spot, which would typically be the earliest one. So it might work. But let's be smart about this. Let's just say that I'm overdoing it, but let's actually find the closest pipe. So I'm going to assume the closest pipe is pipes index 0. Then I am going to look at all of the pipes starting with 1, and I'm going to say, oh, actually, you know what? Let's do this. And I want closest closest d being the closest distance to be the absolute value of this dot x minus closest dot x. Okay. Then I'm going to say let d equal, we can start with 1 here, absolute value of this dot x minus closest dot x. And if d is less than closest d, then the closest is that particular pipe, and the closest d is that new distance. So this is a little quick algorithm, find the closest pipe. Here's the thing though, I don't want a pipe if it's gone behind me already. That one shouldn't matter. I got an idea. Let's get rid of that absolute value thing. Right? Because as long as the distance is so what I can do the pipe's x minus my x, it's positive if it's over here, and I want that to be a lower number, but I don't want it to be negative. So as long as d is less than closest d and d is greater than 0, then we're fine. But what if this is negative? But it wouldn't be at the beginning. Oh, but hold on. Just time out for a second. I have to stretch. I'm looking at it will fail when the bird is between two pipes. You should use an array of raycast in front of the bird as input, distance between obstacle, like how a self-driving car works. Yeah, that's probably what I should do. Closest equals pipes, this dot x. Oh yeah, that should be pipes index I. Yeah, I have a typo on line 34. Yes, I do. As long as the x position of the bird is smaller than the pipe's y position, yeah. So, okay, a couple mistakes here. One is this should be pipes index I. I'm going to change this to say closest is null, and the closest distance is infinity. I love that you can type infinity in JavaScript and it knows what that is somehow, as if that's a number it could store in memory. But what I'm actually going to do here, I think this will work now, and then I can start with 0. right? So as long as it is in front of it, that's the closest one. So now I can say instead of pipes index 0, I'm going to say closest down here. I'm going to say closest here and closest here. And here we go. Now we are ready. Oh, cannot read property top of null. All right, so what's going on here? This dot x minus pipes index I, and d is greater than 0. What do I have wrong here? Because as long as there's at least one pipe, it should always get that first one. This dot x. Oh boy! Oops. So the way I program this, I've got to say pipes, because I took out the absolute value. I've got to say pipes index I minus this dot x, right? Because I want it to be positive, like the pipe, and then it goes past it. Okay, this should be fine now. Or not. Oh, dot x. Dot x, pipes index I dot x. Okay, there we go. So I can do this a bunch of times, and we can see I'm going to get a bunch of random birds that are doing sort of random things. Whew. All right, I think this is going to be a multi-parter coding challenge. I am now wrapping up the end of this first part, because just to summarize, what have I done so far? I have built a system where I have the game Flappy Bird. I have developed a neural network architecture for the bird to read in the state, sort of evaluate the state of the game, make a guess as to what it should do. Should it jump up? Should it not? Based on that. And then I have put that into motion. That neural network is part of the bird object now. It has a brain, 441. And then it has a think function which sends the data about the game into the neural network and decides to go up or not. Now what I need to do is actually implement the neuroevolution part. So I've implemented the neuro part. I designed a way for the bird to make a decision based on how it's evaluating the scene. And what I need to do now is make a population of them and try them all and evolve them over time. So I'm going to take a little break here. I'm going to meditate for a minute on how much my brain doesn't work as well as a simple multi-layered perceptron. And I will be back in the next video to actually implement the genetic algorithm part. Thank you for tuning in and being on this journey with me. All right. Yes, Eric points out the numbers for the pipes are going to be the same for every bird. So do that part in the draw loop. That's true. I think, however, that's a nice optimization and efficiency. But in terms of demonstrating this idea for games where the agents would be in different places and would actually have kind of different inputs, I think I'm going to just leave it there because it's fast enough. I mean, this algorithm is nothing that's really going to be slow. There's like 2 or 3 pipes every time. All right. I feel like, I can't because I don't have time. I wasn't happy with how that went. Maybe, Mathieu, you can like edit it in such a way that I'll feel less like I was lost. It's fine. I kind of want to do this. I have this sort of thing where, I noticed that if I make a coding challenge, I shouldn't worry about this. But my coding challenges that are just one part get viewed a lot more than if they're multi-part. But I shouldn't be optimizing for views. I should be optimizing for making good, useful content. And this needs to be in multiple parts. I mean, I could make it in one part, but then it'll be an hour or so video, and I think it's better to break it up. All right, I don't know. I never know what to do. Your predict method returns an array. Oh boy, that is such a good point. Oh my goodness. Christopher, thank you. Your predict method returns an array. So that's the first thing I need to fix. That's the first thing I need to fix in the next video. Interesting. Let me just check it, see if it's actually like the behavior. Weirdly, just curious. Just curious to evaluate this for a second. See what kind of numbers it's getting. Yeah. Okay. All right. Yeah, just fix the fact that I'm a lunatic in post, please. Thank you very much. I'm sure that'll be possible. All right, what time is it? 3 o'clock. We got to get moving here, folks. 45 minutes. I can do this in 45 minutes. I got through the main part. All right. Get rid of this. I don't think that's doing anything. I really want it. That console log is making me crazy. I don't know why it's making me crazy, but it bothers me. All right. Why am I not using 2 outputs? I probably should have used 2 outputs. Yeah. When I made my example, I did use 2 outputs, but hopefully it'll work with just 1 output. All right, I'm going to keep moving on here. All right. Let's reset the cameras. Did the cameras not go off during that whole time period? It seems impossible that that wasn't. Yeah, I know I removed the 0. I did that on purpose because it's got to be in the next section. Oh, it's so sad because I did that over there and it was like perfect. It flipped and I caught it and it was like really cool looking. Cool. And then I was like, oh, I wasn't in the right camera. Let me just go over here and show my my manual dexterity. Okay, never mind. Moving on. I am back for part 2 of Neuroevolution with Flappy Train. I don't know, Flappy something. You can see here, I now have this neural network, which is driving this circle to jump, get through the... Oh, it's not really working. So the problem is I only have 1. I need to make a population of them so that I can pick and choose the ones that are making smart decisions somehow and making their way through this maze of pipes. But before I even do that, in the chat, thank you to Christopher, a mistake was pointed out, which is that I forgot that my neural network library, just like it expects as its inputs an array of values, it gives you back as its output an array of values. And I forgot about that because even if it's 1 value, it's still coming back in an array. So I need to say index 0 here. So what I want to know is that first element of the array, is it greater than 0.5 or not? The truth of the matter is nothing's really happening yet, so we're kind of getting the same results. But you can see things are possible. All right, so now let's see what we can do here. The first thing that I need to do is I'm going to make a new JavaScript file, and I'm going to call this ga.js. So I'm not going to make a population class or genetic algorithm class. I would like to at some point refactor what I'm doing here into a packaged way that you might be able to just like use it as a library. As part of the toy neural network library, has some functionality for genetic algorithms built into it. But I'm just going to write all the raw code here. And the main thing that I need to do first is I need to change the idea of having a single bird to many birds. And I want to, I'm going to use const. Woohoo! So exciting when I use const. I'm going to make a population total, I'll just call this like total, and I'll make it 100. So what I'm going to do here is I'm going to say I equals 0, I is less than total, and then I++. So I'm going to make a population of birds. Birds index I is a new bird. Then what I'm going to do here is let me just do this here. For let bird of birds, I'm going to use that for of loop to just loop through and have every bird think, update, and show. Now I haven't done I got to fix this thing with the pipes. So let me just comment this out for a second, but let's at least see the whole population going. So you can see, it's kind of interesting. It's definitely like they're doing different stuff. Now, they really are, yeah. Hold on, I got to think for a second. Now, in my example version of this that I made, this is a pause moment for a second. If I go to my example that I made for my class a while back, when it starts, they're really like a much bigger variety of stuff happening. So one thing is, let me change the transparency a little bit. But is there anything else that I'm doing in this example that I'm forgotten about here? Could it possibly just be that having two outputs actually gives more variety? All right, so I got to think about this. All right, so one thing I want to do here, just visually, I want to be able to get a better sense of the birds. So I'm going to look at the bird's show function, and I'm going to say stroke 255 and fill 255, comma 50. Like I'm going to give them some alpha. So you can see that most of them are doing exactly the same thing. There we go. There's sort of a variety there. One thing, I'm just kind of a little suspicious here. Let me try two outputs. Let me see if two outputs actually yields some more unique results. So in that case, with two outputs, what I actually just want to do is something like if output 0 is greater than output 1. So let's try that for a second. It's kind of the same. Maybe I just want to have a bigger population. Yeah, there we go. I just had a bigger population. So I just want to have a bigger population because I'm going to need more possibilities. Okay, so now here's the thing. I need to do something else rather important. I need to eliminate any birds when they no longer, when they hit one of the pipes. So now what I need to do is, as I'm going through here, I also want to say for let j equal birds.length minus 1. J is greater than or equal to 0, j minus minus. And I could use filter or something, but I'm not going to use filter. I'm going to come back to that another time. And then what I want to do is I want to have this. If pipes index I hits birds index j, birds.splice j comma 1. So this is now me deleting any birds that stopped living there, that hit one of the pipes. So let's run this and see, sketch.js error. Oops, I forgot a semicolon here. Okay, let's try this. All right, so let's see here and see if we can get, did any of them make, none of them made it through. That's not a good sign. So I would like to at least kind of live in a world where, so I'm going to make it a little easier for them. Right now in pipe, I'm going to increase the spacing to 175. So I'm just going to make that space between the pipes a little bit easier. Yeah, one made it through. Because I just want to at least kind of increase the chances that there will be some that outperform others. And I'm somewhat random, but let's see. So this is good. Okay, so we're getting somewhere. Now what I need to do is I need to think, what are the things I need to think about when I have a genetic algorithm? Time out for a second. Is there like a, nah. Yeah, different colors is a good idea. So I should do that. Okay. Thinking. Oh, I think I need some water. So Shadow Plays in the chat is saying, Dan, you should input the distance from the pipe and the bird too. While that is important, I'm basically getting that by the nature of the pipe's x position, because the bird never moves. So if I know the pipe's x position, I know the distance. So the neural network should be able to kind of learn from that. I could also just make a much bigger population, but all right. Okay, so a couple things. Number one is I know I'm going to need to have a new generation. So let's actually let's write a function called next generation. And just for right now, I just want to get sort of like the process going here. For next generation, I'm going to say for let I equal 0, I is less than total, I plus plus, birds, index I equals a new bird. And I know that in the main program, if at any point birds.length equals 0, then call next generation. So now if I run this, we should see that at least it's going to let these run as long as there are some birds. And then next generation is not defined because I forgot to add it here to my index.html file. So I need yet another JavaScript file. I'm going to call it ga.js. Okay. So now, as soon as all of the birds run out, 2 made it through. No, come on. Whoops. Did I forget to hit save? Next generation. Did I call it new generation? No, next generation. Oh, I know what the problem is. Why do I make these errors? I put it in library/GA. Okay. Come on, let's move it along, folks. All right, one more time. Let's, with feeling, everybody. Oh, look at those 2 birds making it through. Oh, look at that, genius. That is a genius bird already. Come on, go, you can do it. Oh, I jumped right over it. Oh my God, there's the music. Come on, go up. Oh, okay. So you get the idea here. Now, I haven't involved in that. Was just very exciting for me. My life is very strange. Okay, so what I need to do, though, is this is no good. I don't just want to make a whole new set of new birds. I want to evolve them from the previous generation. So in order to do that, I need some sort of fitness. And so I'm going to build into each bird object, I'm going to give it a score and also a fitness. And it's probably not necessary for me to have 2 variables, but the way I'm thinking about it right now, it's just going to make it easier. And so the idea is that the longer a bird lives, the more it increases its score. So in update, right, every time update gets called, it should get another point. So I'm going to say this.score plus plus. Okay? So every time update is called, its score goes up. And then what I want to do at the beginning of next generation is I want to calculate a fitness for every single bird, and I want all those fitness values to be normalized between 0 and 1 and add up to 1. And if you watch some of my previous genetic algorithm tutorials, you'll see why I'm doing that. I need each fitness value to be a probability that it gets picked for the next generation. So the first thing I'm going to do in next generation is I'm going to calculate all the fitness values. So let me break this out into some functions. Calculate fitness. So in calculate fitness, what I'm going to do is for every bird, I am going to, first I need to do is get the sum. So I want to say, I know I could use a higher order array function here, but my brain doesn't think that way. Sum plus equal bird.score. So what I want to do is first add up all of the scores. Then, for each bird, I want to say bird.fitness equals its own personal score divided by that sum. So this is a way of kind of calculating and normalizing all the fitness values. Now maybe I need to make this exponential in some way, or be, power law or some kind of fancier way to think about how the score maps to fitness. But I'm just going to use this sort of like linear way of doing it right now. I could square the score. So let's see. Fitness equals bird.score divided by sum. So this works for calculating all the fitness values. Now I've calculated all the fitness values. I then need to, I'm moving right along here. Then what I need to do is I need to pick, all right. Let's hold on for a second here. Time out. I'm going to go to I have a genetic, I know where it is. Week 8, GA slides, download. My battery's at 100%. Isn't that nice? All right. All right. So if you remember from it, or if you happen to watch any of my genetic algorithm tutorials, I go through this presentation which walks through the actual algorithm itself. So what I need to do, so I have evaluated the fitness of each element of the population, but here, if you look at the next step, I need to make the new population. I need to n times pick 2 parents with a probability according to relative fitness. This is so that I can apply this idea of crossover. Take half of the DNA of one and half of the DNA of others and mix them together. Here's the thing. I'm going to, for the purpose of this video, do a simplified version of crossover. One way that I could do a simplified version of crossover is not do crossover at all. Instead of taking 2 elements and combining them, I could just take 1 element and make a copy. So I'm going to take the ones that do well and just make a copy of them. And the reason why this is going to be so easy is because I already have, as part of the neural, no? Yes? Why did this camera go away? It's on. Oh, it became loose. Cable got loose. Because I already have, as part of the neural, over here, as part of the neural network class itself, a copy function. And guess what? I have a mutate function. And if I come back over here, we're going to see the next step is mutate. Mutate the child's DNA based on a given probability. So this is what's nice, that I did this in a previous video. I added these things to the neural network library that I'm using. So now I'm going to go back. Oh, and let me just minimize this. I'm going to come back here, and I'm going to say, instead of just making any new bird, I need to pick 1. I need to write a function, pick 1, that is going to somehow return one of the birds based on with a probability mapped to its fitness. So here's the thing. Where are all the birds? Where have all the birds gone? I kept deleting them. Anytime it hit I deleted it. Here's the problem. I think I need a backup. What's going to be nice here is say let birds equal an empty array. I'm going to have an array called saved birds. And I guess what I could do is, maybe what I'll do, this is a little bit silly, but every time I delete one, I'll just say saved birds dot push pipe, because I'm pretty sure if you delete something from the array, it gives you, it returns, right? If I say pipes index 0 dot splice 1, pipes splice 1 0 comma 1, right? I get that pipe object. It gives me that pipe object. Oh, it gives it to me as an array. So what I need to do, but I think I can push the array into it And so this should work, right? If I now have, if I make an array, which is an empty array, and then I say A, oh, shoot. Okay, I know the picked one. Here, hold on. No loop. Thank you very much. No, no. Okay, now I can do what I want. I can do whatever I want. A dot, so let P equal pipe splice 0, 1. So P is this array with one pipe into it. Then I could say let A be an array, A dot push P. And so now let's do what A is. Oh, A is an array with one thing with a pipe in it. So that works. All right, just testing out my idea. So what I can do now is when I'm done, back to sketch, right? As I'm removing the birds, I can save them. So that now when I go into the genetic algorithm, pick one, I can pick one out of the saved birds. So let me just, for the sake of argument, just say let child equal random saved birds. Return, I just want to see that this works. Right? So I'm just going to, I'm not using the fitness yet as a probability, but I just want to pick a random one just to see that the workflow works. Return child. So birds index, and then I'm also going to say child dot mutate 0. I'm going to have a 1% mutation chance. So I'm going to let it mutate, or 10%. I'm going to mutate 10% of the weights of the neural network, and then I'm going to return that. So let's just see if this works. And then after I'm done that, I also have to clear the saved birds. So empty that out. So this now, every time I want to make a new generation, I should calculate all the fitness values. I should get however many new birds, clear out the saved birds, and go again. So here we go as I'm waiting for the next generation. Come on, birds, you're doing too well. Child.mutate is not a function. Of course, child.mutate is not a function. Oh boy. I just realized what's going on here. Just time out for a second. Oh, really? Is this not working the way that I think it is? That it's not actually, like if I look at saved birds right now, whoops. What's going on here? Oh my God, where did I end up here? There we go. Oh, why did I put the pipe in the saved birds? That makes no sense. I put it in the pipes off screen. Oh boy. Oh, why? Why is coding like this? It's much harder when you're trying to do a tutorial and on a live stream do this coding thing. Oh my goodness. Oh, no, it's 3:20. I gotta hurry up. All right. So many problems with this, I don't even know what to say. Okay, there was a little bit of a jump cut there because I really went off some like weird direction there that made no sense. I don't know if you noticed and were yelling at your television machine thing that you're watching me on, but for some reason I put this down here. I started adding the pipes to the saved birds, so apologies for that. This is not where that goes. The pipes get removed just when they go off screen. It's the birds that I want to add to these saved birds. Also, I'm not so sure. I might be making an array of arrays. Let me just run this for a second. Let me let a bunch of birds die. And let me look at saved birds. Yeah, I made an array of arrays. We don't want that. We want an array of birds. So I could probably use concat. But let me just push in the one thing that I'm removing just to fix that. And we can see here there's no birds in there. And then now I have an array of birds. All right, so that's better at least. Now, pick one is still going to have a problem. So why is pick one good? I sort of stopped thinking about what I was doing here. I'm taking that bird, I'm not making a copy of the bird, I'm taking that exact bird object and putting it back into the birds array, which is fine, but if I want to mutate it, I need to mutate its brain, the neural network. So to do that, I think what makes them, I mean, just as a quick, I could just say, like, let's put in the bird class itself, let's write a mutate function. And mutate function, I'm going to say this.brain.mutate 0.1. So I'm just going to kind of have this hard-coded in here that when a bird mutates, its brain mutates. And I think I can get away without actually making a copy of the neural network. Oh, no, 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 no. No, I want to make a new bird with the same neural network. I think that's going to be, I'm going to be better off. Because otherwise I've got to reset all of these numbers and values. Its velocity's got to go back to 0. So I want to make a copy of the bird. And I kind of want to, but I don't really need to make a copy. I just need to make a new bird with a brain. So if brain, right, if I create a bird with a brain, a bird brain, then I'm going to say this, and I'm going to make a copy of it just for, it's probably unnecessary, is brain.copy. So I'm going to do that. If otherwise, if I'm making a bird without a brain, I'm going to just make a bird with a new blank neural network. And there's already a copy function. This way I'm setting myself up for future success. If I want to do crossover, it's going to be a little bit easier. Then here, what I want to do is in pick one, I pick a random bird, but I return, and then I say, let bird equal, and then I'm going to say let child equal a new bird with that bird's brain. Oh, this is very weird. And then I'm going to say child.mutate. Okay? And then now this should get me the right idea, right? I'm picking a random bird out of the saved birds. I'm making a new bird with the previous bird's brain. I could do crossover here, right, if I want to do crossover, and then I'm mutating. Okay, so let's give this a whirl. Here we go. Did they all die? I don't have a console log for, yeah, there we go. Okay, so this is working. I probably should clear out the pipes. So the other thing I should do, I think, is, that would make sense, is when also, as soon as there's a new generation, I should probably say pipes. I should just like, let me just add one pipe. And actually, you know what I'm going to do? I'm going to make this my own counter. This is a little bit unnecessary, but I just want to reset the counter back to 0. Counter plus plus, and I'm going to have a global variable. Whoops. Sometimes I can't type. I'm going to have a global variable called counter set equal to 0. Okay? So I just want to do that because I want to, like I don't want to, I want the whole game to restart. There are 2 pipes though at the beginning for some reason. Why is that? I'm looking at sketch.js. Because I add a new pipe in setup, which I no longer need to do because as long as I put this first in draw now. Okay, there we go. Okay, so now there's one pipe. All the birds are trying to play Flappy Bird. As soon as they all go away, the whole thing starts over. So now we have the workflow. We're actually good to go here. We are good to go. The problem is I need to pick them based on their fitness values. Here's the good news. I have a function. This comes from my traveling salesperson coding challenge. It comes from this GitHub issue that was filed on August 5th, 2016 with this particular algorithm for picking an element from a population based on a given fitness. So I'm going to go over to here actually, and I'm going to grab this exact pick one function, and I am going to bring it over, and I'm going to put it in this. So if you want to review how this function works in more detail, you can go back to my previous videos, but I'm just going to paste this right in here. And the idea here is that at the end, list index is that particular bird that I want. And this made I don't know why I have slice here. I can't remember why I did that. But basically, what I'm doing here is now instead of picking a random one, I'm going to pick it from that list. Now, I wrote this function with arguments, but the good news is I can take this stuff out. And what I'm really doing is I'm saying, OK, birds index.fitness. That's the probability, right? I'm picking one thing from a list based on probability. Those were the arguments here. I'm picking something from a list based on an array of probabilities. So now, wherever I see list, what I mean is birds. And whenever I see probability, I mean birds fitness, the fitness of the bird. So this is birds index. And I don't know why I have that slice there. And then, so this is good. I'm good. There we go. So this is an algorithm for choosing a random number and seeing where it falls into the sort of spread of all the probability values. And again, you could go back to my video where I specifically talk through this entire algorithm. But I think this is going to do it right now. So let's now run this code. That's really the last piece. And I'm going to let this run for a little while. And no, I'm not, because cannot read property y of undefined. So what did I mess up here? Let's take a look here. Console.log bird. All right, let's see what's happening here. Pipes.js 18. I didn't even get that far. I was so excited that I was done. Where am I? Pipe.js 18 hits bird. And where is that? That happened, it's being called in sketch.js line 28. If pipes x birds index j, save bird splice. Why the bird doesn't exist. Oh, good thing that happened. Did anybody see what I did wrong? What did I do wrong? Choose from saved birds. Thank you. Thank you. All right, I clearly made a mistake. Thank you to IHORL in the chat. I need to be using saved birds. Remember, birds has nothing. So I need to say saved birds, right? Saved birds. So that is something I definitely need to do. Is that the problem that I'm having? I think I might have a different problem also. Yeah, so I think because once all the birds are gone, it's kind of doing this one more time. Next generation. Right, it seems to only have a problem after I call next generation. So I must not be so let me go here. Let me say console.log next generation. Console.log birds. Let's look and see what's in there. Let's see what's going on here. Okay, so here we go. I really should make it so that the pipe comes more quickly, because now I have to wait. I have two functions called pick1 in the code. Did I not even realize that? So I have a lot of undefined, a big array of undefines. Did I leave like, oh my goodness, I left this function in the code. Why is that there? All right. Let's see if that was like using this other pick. Okay, next generation. All right, we're getting somewhere now. Cannot read property fitness of undefined. Okay, so here we go. Cannot read property fitness of undefined. So let's take a look at saved birds, and let's take a look at index. All right, here we go. This is a lot of debugging in this particular video. All right, whoa. What? Line 16. Oh, it was going through all this. It got through all of them. Weird. Are the fitness while r is greater than 0. All right. And then what happened? And then we got to the end. Yeah, of course, because it never. So let's look at the array of 250. First of all, let's make our life a little bit simpler by just doing this with 10 birds while we're trying to debug this. And that way we can have an easier time of figuring this out because there's only 10 of them. So lift, velocity, I want to check the fitness values. Fitness values of all these are 0. So my fitness calculation is somehow messed up. Let's look at that. So let's look at calculate fitness. Let's console log sum. Okay, let's console log sum. I have to wait. 0. That's not good. Bird.score. Let's look at all the birds' score. Whoops. Score is 96. Score is 96. So that's right. They're getting a score. Oh, I need to do saved birds here. Saved birds. So everything here has to be saved birds. I probably should do it the other way around. Okay, there we go. The fitness calculation also needs saved birds. Probably everybody in the chat has been telling me this for like the last 5 minutes. So now I feel pretty confident here. I probably shouldn't. I'm going to take out my console logs and let's see what happens. Let's see, can we get to the next generation? Yes, we got to the next generation. Now, am I seeing anything evolve? I don't think so because I only have 10. So let me give myself a lot more birds. Let me give myself a lot more birds. Back here, I'm going to say, let's give myself 350 birds. And let's run this sketch. All right? I'll be back in just a few minutes. There's 1,000 people watching? Come on, birds. You can evolve. Go, 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 go. Ah! Oh. What time is it? 3:40. I'm doing okay. So I am not fully confident that, I know there's a bunch of things I definitely want to improve here. All right, so I'm back. It's kind of like they got a little bit better, but there's some things that I really want to improve here that I know that I'm pretty sure will make this perform much better. First of all, it's pretty silly that I have to sit here and watch it for like a half or an hour to see if it will evolve. And there's something I could do very quickly to speed this up. Because if you think about it, I don't need to draw the game at 30 frames per second. I can just run the game really, really fast and just kind of show it to me every once in a while. So I'm actually going to create, a little slider here. I feel like this should be part 3. I'm going to make a part 3. Because if I'm making it multi-part, I might as well have a part 3. So hold on. All right, so this did okay. They seem to be improving. There's some good ones in there that are jumping, but I'm going to wrap up this part 2 where I finally applied the actual genetic algorithm part to evolving the neural network with a population of these things. And what I'm going to do is I'm going to do one more part where I'm going to improve this. I'm going to do a few things. Number one is I'm going to speed up the process so I can get it to evolve a lot faster. And I'm going to change the way mutation works, which I think will give me it will help me find an optimal solution a bit faster. So come back if you want. I will be here again in part 3. Okay. Welcome to part 3 of my Neuroevolution Flappy Bird coding challenge. All right, so, come on, jump, jump, jump. Oh, yes. Oh, that looks like it probably should have hit the pipe there. But anyway, that aside, look at these birds. They're really trying to get through those gaps in the pipes. All right, so I want to do a few things to improve. Number one, this is a bit ridiculous that I have to sit here and wait and let it run. It's kind of enjoyable. I mean, I have to go soon, so I got to speed this up. So here's one thing I'm going to do to speed this up. I don't need to, all of the logic that's driving the game, I could just do that many, many times per frame, right? I don't actually need to draw and show the animation. So for example, so one thing I need to do is separate out all the logic of the game from the drawing. So one thing I'm going to do is I'm going to take out pipes.show here. This is like counter is part of the game logic. Looping through all the pipes and checking them, that's part of the game. Looping through all the birds. If birds, this is part of the game. So but drawing is not. So let me take out bird.show. And now I'm just going to, at the end here, say let bird of birds, bird.show, let pipe of pipes, pipe.show. This should be exactly the same. Nothing has changed, but now, and I might as well take the background and put the background here. So this is all the drawing stuff. And now what I'm going to do is I'm going to say let n equal 0. N is less than cycles. I'll call it cycles, n++. I'm going to do all of the game logic stuff many, many times. Oops, which goes all the way down to here. So, and then I'm going to say let cycles equal 100. So watch this. So now this is just like doing it really, really fast over time, but I want to be able to like speed it up and slow it down also. So one thing that I can do to do that is I am going to say let slider equals create slider. I'm going to make a slider that goes from 1 to 100 and starts at 1. And that, I'm just going to say slider.value. So instead of a variable called cycles, I'm just going to use the value of that slider. So now I've got a little slider here. I can speed things up and I can slow them back down. So this is going to help me a lot where instead of having to like speed up the video that you're watching, if I'm editing this after the fact, I can actually just do this. So in fact, I could let this go for a little bit and then I could come back and see like, how are we doing here? Do we got one that's doing pretty well? So, but here's the thing. I also think there are some things that I really need to do to help the evolutionary process along. One thing is I'm going to go into the neural network code and look at how I'm doing mutation. So this is the mutate function. So first of all, I'm a little suspicious here. I want to make sure that mutation is really happening. So let me at least console log test. I just want to see, I just want to see that this is happening in the code somewhere. And I'm going to go back to sketch.js and just have like 3 birds because I don't want it to go crazy. So as soon as the 3 are done, I should see mutate. Yeah, so I got a bunch of mutations. That's good. So that is being called. So hopefully the weights are being changed. But you know what might work better, I think, I have a sneaking suspicion, is that it might actually help me to, rather than when I mutate, pick an entirely new weight. So, you know, what's going on here? The internals of the neural network are something that I haven't talked about in this series. That's really something reserved for my other videos about how neural networks work. The only thing that's relevant in this series is the inputs of the game come in, the outputs come out, and the output tells me whether I should jump or not. But what's actually stored inside the neural network are a bunch of numbers between -1 and 1 for all of these connections. And so mutation means just pluck one of them out and give it a new value. But if it's one that's doing pretty well, if I just were to like tweak the value a little bit instead of just giving it a whole new value? And also, what if I were to just tweak it a tiny bit? So use, one way I could do that is use a Gaussian distribution of random numbers that cluster around like a mean of 0, but are often like, so just like I want to give each a little bit of a nudge. So let me come back over here, and I'm going to have to build in Gaussian random number generation into the library, the neural network library, but right now since I have p5 involved, just to fix that, I'm going to comment this out and I'm going to say return val. So this would be just like me adjusting the value a little bit, right? Return the actual value changed by a little random amount. But I think I'm going to, because when I did this for my class last year, actually, I remember using random Gaussian, which is, this is now a p5 function from the p5 library. This doesn't exist in JavaScript, so I've got to implement that into my library, but it'll work for now. The mean would be 0, and the standard deviation would be like 0.1. Let's try that. So let's see how this goes. Oh, and I took out the console log, and let's give this a whirl now. All right, so I'm going to speed this up. And I'm also, oh wait, there's only like 2 of them. So the other thing I need to do is let's give myself a nice population. Let's try 500 of these. All right, so there's 500 going. I'm going to speed this up, and I'm going to let this run for a little while, and I will be back. But at least... Let me look at the chat. Okay, let's see how we're doing here. All right, so it looks to me like we've done it. There's so much variation in here, but I've evolved it for now 76 generations. And what we see here is that we've got a bunch that are still alive. And there's probably one in there that has pretty optimal weights, and it's making it through. Now, one thing that I would really like to do is, it's kind of more fun to watch this if I show only the one that's kind of doing best. But at some point, there'll only be one left. But I think we're pretty much there. Here's some things that you might want that I would love to do with this in another part, but I'm going to leave them as exercises for the viewer. Come on. There you go. Started over. So a couple things. One is that I can keep track of the single agent, the single bird that has done the best over all time, over all generations, and I could save that in a variable like the best bird, record bird. And what I could do is actually I could download those weights. I could save those weights to like a JSON file, its neural network configuration to a JSON file, or even just save it in memory. And I could always just click a button or something and say, let me just see this one. So that's something I would really love to add to this. It's actually, I might as well just show it to you because the example that I made for my course, which is here, is essentially exactly the same, but there's a couple different things. So one is so let me just ramp up this speed here. So let me let this run for a little while. The game's maybe a little bit different in this one, so one of the things that I like about this is once I've let it run for a little while, I can just click run best so far. So now, and I could speed this up a little bit. But I think I better train it more because I didn't get a really good one. So this is the idea of being able to just run the best one that's done, that has the best high score. Oh, look at this. Okay, so now I'm gonna do this. So we can see this one that kind of has a pretty good sense of how to play the game, kind of running, just watch that one on its own. It's very satisfying to watch. I'm like amazed that it's doing it. So that's one thing that would be worth as an exercise trying to add to this implementation that I made. Now, once I even do that, I could save it to a file. So there's actually in the toy neural network library, there's like a save JSON, I think, function. So I could save it to a file to reload later. So if I'm training it all day or for an hour, I could save it and bring it into another environment. That's one thing. Another thing that I might want to do is I could probably optimize the fitness function quite a bit. For example, what if, and this is a thank you to Versatilis for this, this suggestion, what if I actually scored not just how long it lasts, but how well it maintains its Y location in between the top and bottom of those two pipes. So that would be, you could probably think of many other ways that you could optimize this. So saving it, making the interface, now we could also take this and we could go and add all the fun coding train design elements from the original, from that Flappy Bird clone repository. Pull requests can now start, the floodgates are open, so we can make a version of this that maybe has even like a saved, pre-trained Flappy Bird agent. I'm going to take, I'm going to pause for a second to just look at the chat. Whoops. Because I have to take a break. Just hold on 1 second also. Hey, so just like 5 more minutes, I'll come grab you guys. Okay. Oh, good, sorry. Just don't worry, this live stream has more. Some stuff is going to happen, but in about 10 minutes. So, let me see here. Okay. For the fitness, shouldn't you divide the bird.score with the score of the best bird instead of dividing it by the sum of the scores? No, I want it to be, no, I don't want the highest fitness to be 1. I want all the fitness values to add up to 1. That's the way the probability map works. Use the y velocity as input. Okay, great. So another suggestion that just came in from the chat is the actual y velocity as an input as well, because if I'm already moving up, maybe I shouldn't jump versus if I'm moving down. So that's something you can add. Oh, and here's another one. What if actually, instead of my own sort of manual what if actually instead of my own manual feature extraction where I'm kind of evaluating the Flappy Bird scene to make inputs, what if just the pixels, what if it was just the pixels of the game itself that became the input? But now we have a problem, right? We have a problem, which is that I am looking at a scene. Let me just speed this up. With, come on, let me just refresh. Right? I am looking at a scene with many, 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 many birds playing all at once. If I want to use the pixels of the game as input, I cannot have the whole population there. I need to have just the one current bird that is playing. So I have to create a graphics context for every single member of the population. And in fact, this Flappy Bird game is so simple that actually, as the player plays the game, it doesn't affect how the game plays out. Imagine if I were doing my asteroids coding challenge. I can't have them all play in the same world, because if one shoots an asteroid, the other one hasn't shot that asteroid. The game is changing for all of them. So another thought experiment could be, how could I actually make this work where I see, instead of all of them playing within one canvas, a grid of the whole population, lots of little versions of the game all playing together. To be honest, to make this work, I don't have to see anything at all. But try doing this with another game. Can you find my snake challenge, my asteroids challenge, my Frogger challenge? Any of those now could be trained, a bot could be trained to play that game using the exact same technique. So I'm just looking at the chat. When I'm inside the pipe, I chose the next pipe. Yeah, that's true. And people are telling me quickly add that y equals height kills the bird. No, so I'm not going to add all these things. They need to be killed when hitting the ground. I didn't know that. That's part of Flappy Bird. All right, from the chat, I also just learned that I have a couple mistakes. One is that supposedly, I guess in the game Flappy Bird, if you go to the bottom, you die. So I don't have that implemented. It'd be interesting to see if it could solve itself with that. Also, the way that I'm finding the closest pipe, it's no longer the closest pipe right as it gets right up to it. And so I really should not consider it to be the closest pipe until it's gone all the way past. But anyway, there's lots of little tweaks and minor things. So I would gladly encourage you to create your own versions of this and submit them as community contributions. And I'll look at them and maybe do another live stream next week or whenever I do the next live stream going through and showing some of these community contributions. All right, so thank you very much for watching this 3-part coding challenge. If it was really in 3 parts, I think we'll do 3. I look forward to doing many more coding challenges, hopefully maybe around more neuroevolution coding challenges, because this is kind of one of my favorite topics. Okay, thanks for watching, and I'll see you in a future video. All right, so Shadowplay asked, Dan, shouldn't the pipes have the same position every time you die? No, I precisely don't want them to. I want to train an agent to be able to play any course of pipes. I want it to be able to work with wherever the pipes may be. I don't want it to learn just one specific sequence of pipes. Can you check if I can turn on live subtitles? Let me try. So I'm in my live dashboard. Does anybody know where that is? So I'm looking. I can't believe there are 1,000 people watching now. This is nuts. I have never had 1,000 people watching. All right, stream options, normal latency, enable DVR, monetization, cards. I don't see an option for live captions, unfortunately. Interesting, Carmen in the chat writes, for someone who has no knowledge of coding, this was actually super informative. I started watching knowing nothing, and now I kind of understand what's going on. That's amazing to me. So if you're watching this and don't have any knowledge in coding, I might suggest going through my beginner P5 tutorials. So it's just almost 4 o'clock. Yeah, I think once before I had 1,000 people watching live. Usually it's between 500 and 600 people. So let me just mention what I'm going to be doing next, now that I've gotten through this, is I'm going to start using TensorFlow.js. So one of the things that I'm going to do next, the next thing I'm going to do, and I'm going to be integrating TensorFlow.js into some examples for the ML5 library, ml5.js@github.io. So this is a library being developed at ITP, which is built on top of TensorFlow.js. I'll come back and talk about what all these things are. But if you recall the doodle classifier I made, for example, I want to remake that doodle classifier with a much larger data set and something called a convolutional neural network built on top of TensorFlow.js. It'll be much, I assume and hope it will be much more accurate and robust that way. All right, so let's check back on our bird. So what I'm going to do right now is, it's funny, my preview has stopped working, but I assume people can still see me. Hello to Nigeria. That is unbelievable to me that there's people all over the world watching. Read some random numbers. All right, so I'm not done for today. I'm done with this project, but this live stream is going to continue for about an hour more. I think what I'm going to do, I'm trying to decide whether it should, I think what I'm going to do is, is it better for me to, I need like 5 minutes to get set up with some guests. I should just say what the guests are. Why am I I have this thing where I want it to be a surprise, but there's no reason for that. So I have some guests who are coming, Aaron and Guillermo, who are going to talk about their work with p5.js in Spanish. And they're actually going to show some new materials that they've been making to teach programming in Spanish. And they're going to do a tutorial about p5.js in Spanish. So that's what's going to happen, but it's going to take me some time to get that all set up. So I'm trying to decide if I should stop the stream and just restart it, or if I should just like go to a scene that, like I could put this on. You could be forced to watch this on loop. I don't know if I want to torture people with that. So I think I'm going to just hit stop streaming to give me 5 minutes to redo the microphone setup and let them get in here and get a new laptop to be comfortable. So I'm just going to pause the live stream, just mute sound. Don't stop. People really don't want me to. I'm going to make sure it's okay with it. Hold on. I'm going to mute my microphone. My microphone's back again. I'm gonna bring Aaron and Guillermo in here, and I will introduce them in a moment. So you're just gonna see people shuffling around. But I'm gonna mute my microphone and put on this music.
Testing.
It's working. It's working.
Okay.
Okay, we got sound.
Hello, everyone.
Okay, sound is on, so you can. We're just gonna add one more mic. So let me mute it just in case some horror. Hello. Okay, I think we're back. If anybody, before I start introducing the guests, if you're watching this, if you could just let me know that the sound is okay. So actually, I could listen here. Hello, 1, 2, 3.
What about me?
Yeah, you're
Cool.
great.
Okay.
Okay, so it might be this one I sound a little bit quiet. So maybe I'll turn this one up. All right. All right. So, oh my goodness, I'm getting like a phone call here. This is what a disaster. Okay, so I'm going to take my cloaking device laptop, and I'm going to move this over here because I'll come sit over here once you guys start. I'm going to watch the chat to see if there are questions. And so, okay, so we have two guests. I'm gonna switch the mic quickly to the second guest. Come on over here, Guillermo. Let's see if this is Aaron and Guillermo. I'll let both of you introduce yourself as well. They're here to tell you about work that they've been doing with the p5.js, with the Processing Foundation, with the p5.js project. So they're going to do a short little walkthrough presentation about what the project that they've been working on and how to more about it. And then after that, we'll take like a minute or two break. Then they're also going to do a tutorial as well for total beginners, but it's going to be in a different language. So if you speak Spanish, you're in the right place. Okay, so let me try to, not too awkwardly, hand you this mic. So if you put that in your pocket, it is kind of like, this is actually one of these like Madonna earpiece mics, but you can just clip it to your shirt is what I've been doing.
Thank you.
And then and what I would suggest is, this is the laptop that, so if both of you come over more to this side, okay. you come in here and you have perfect, and you have the website
Cool.
like
Yeah, I'm gonna.
this, but I wouldn't full screen it because that way, because where you're standing, you can see is like over here.
Cool.
Okay, let me just check the chat. You guys can start. Go ahead, sorry.
We start?
Yeah, go ahead. And so, just so you know, yeah, you can give your attention to the people who are watching who are there.
Okay, cool. Hi, super exciting to be here at the Coding Train. My name is Aaron Montoya Moraga. This is my friend Guillermo Montesinos. We are both artists and Chilean programmers. We are collaborators of p5.js by the Processing Foundation, and we are teachers of Introduction to Programming using p5.js in our own collective with 3 more friends. It's called Coded, and it's based in Santiago de Chile. Today I'm going to be talking in English, and Guillermo is going to be saying the same things I'm saying, but in Spanish.
Hola, ¿cómo están? Yo soy Guillermo Montesinos, él es Aarón Montoya Moraga, somos chilenos, somos programadores, somos artistas y desde hace algunos años somos colaboradores con el proyecto P5JS de la Fundación Processing. También enseñamos a programar a personas que les interesa la programación creativa en Chile a través de nuestro proyecto que hemos comenzado hace un par de años con otros artistas y programadores chilenos que se llama Code de Escuela. Hoy tenemos la felicidad muy grande de poder compartirles dos nuevas noticias respecto a P5JS en particular.
Yeah. So today we're here to tell you two great news by the Processing Foundation regarding p5.js. So p5.js is a JavaScript library, right, that allows you to do creative programming on the web. And starting today, as you see here, this is the p5.js website. It lives on p5js.org. And now in this upper right corner, you have a link, you have a button that says ES, and you can click on it, and now the website is available fully in Spanish.
Entonces el primer anuncio que tenemos que hacer es que la página de P5JS, que es p5js.org, que siempre ha existido en inglés, a partir de hoy también está disponible en español. Como decía Aaron, en la parte superior derecha de la página web está el botón ES, que si lo presionamos podemos convertir la página, podemos traducirla al español, pero también podemos acceder a ella a través de la URL p5js.org/es.
So the first section that we're going to see today, you have the descargar section, which means download, where you have a link to download the whole p5.js library as a JavaScript file, and also the files in a separate way, because here this complete version also contains an empty example that you can fill in with your code.
La primera parte, o por donde deberíamos empezar para trabajar con P5JS, es descargando la biblioteca. Esto lo podemos hacer desde la pestaña Descargar, en la cual podemos encontrar la biblioteca completa o los archivos por separado escritos en JavaScript, dependiendo de los proyectos que queramos realizar.
The next part is called empezar, which means getting started. So here you have a whole tutorial about how to start from scratch. So it tells you how to use the files you download, and then how to create an HTML file that loads the p5 library, and then how to start programming in p5 with the setup and draw functions. So this is a whole tutorial of how to do your first software using p5.js.
Ahora, si nunca has programado, o si nunca has programado en P5JS, si nunca has programado en JavaScript o en HTML, la página de P5JS tiene un tutorial para empezar desde cero. En este tutorial encontraremos cómo crear un archivo HTML básico, cómo descargar la aplicación P5JS con el ejemplo en blanco en HTML y en JavaScript, y cómo hacer nuestros primeros bosquejos, nuestros primeros dibujos en P5JS, programando en el servidor local, en el computador, localmente digo, usando un editor de texto como Sublime, Atom, etc., según la preferencia de cada uno, y así dar nuestros primeros pasos en este mundo interesante de P5JS.
So continuing, the next section would be the reference. This is a great part of the website where you can check every function and every variable that is available in the library. You can read about it. So for example, if you go to alpha, you have a working example that you can edit if you want. You have a description of what the function is for. You have a syntax section which tells you how to write the function and use it. And any parameter that's there, you also have a description of what it is, what type of variable it needs. And all of this is now available in Spanish, and that's for every function and variable.
Para todos quienes están comenzando en P5JS en español, la página más importante o la parte más importante del sitio web es la referencia. La referencia de P5 se caracteriza por contener información muy detallada sobre las funciones y variables que componen la biblioteca, como por ejemplo, si revisamos alguna, la función elipse, podemos ver que la función está descrita con un ejemplo animado, el cual yo puedo modificar en vivo, por ejemplo, cambiando el foco de la elipse. Esta función en particular dibuja una elipse o un óvalo con dos focos, X e Y, y si yo lo modifico la construcción de la forma. También la función es descrita en cuanto a sus argumentos, los cuales están descritos en detalle.
The last section we want to talk about is the libraries part. It's called bibliotecas in Spanish, where you can check out all the other libraries that you can use on top of p5.js. There's also the learning part, Aprender, which has more tutorials about different components of the library. And there's the examples website, the ejemplos, where you can go and see a working example of P5 with the description in Spanish and a working sketch with all the comments in Spanish. And we're super excited about about all these sections. Let me go back here.
Posteriormente, si seguimos revisando la página, podemos encontrar información adicional que nos permite ir avanzando en nuestro aprendizaje de cómo programar con P5.js. Y llegamos al apartado de bibliotecas, donde podemos ver la descripción y podemos descargar también las otras bibliotecas que giran en torno a P5.js y que nos permiten desarrollar proyectos más complejos, como p5.dom para interactuar con el browser, o p5.sound para poder generar sonido o capturar sonido o trabajar con sonido en vivo en nuestro navegador. También contamos con la página Aprender, en la cual existen algunos tutoriales para poder empezar, para poder entender cómo funciona P5.js o cómo generar un servidor local en nuestro computador para correr aplicaciones más complejas. Finalmente, y muy recomendable para quienes están comenzando, es interesante revisar el apartado de ejemplos. Este apartado muestra algunos ejemplos que se han desarrollado en P5.js, los que podemos, por ejemplo, mirar en cuanto a su código y ver cuáles son los resultados que generan el canvas del browser al ser ejecutado.
That's our first announcement, and the second announcement we want to make today is that starting today, there's a new website by the Processing Foundation. It lives on processingfoundation.press, where we're going to make available books. And the first release is Introduction to p5.js in Spanish. Yeah.
El segundo anuncio que queríamos comentar el día de hoy es que en este momento está siendo lanzada la página processingfoundation.press, que tiene la particularidad de ser un espacio en el cual la Fundación Processing irá lanzando contenidos, particularmente libros, para poder aprender a programar en sus distintas herramientas. El primer libro que se ha lanzado es el libro Introducción a P5.js, que es la traducción del libro Getting Started with P5.js, escrito por Lauren McCarthy, Casey Royas y Ben Fry, y que ha sido traducido al español por Aarón Montoya Moraga en un proceso que duró aproximadamente un par de años.
So this book is available in a pay what you like mode. So it says here $10, but you can also say 100 or 0 if you want to download it for free. And soon it's also going to be available to download to order as a physical copy, a physical book from Amazon. Yeah, we're super excited about this because it assumes no previous knowledge. You can just get the book and start from scratch learning how to program for creative things. Yeah. What else I was gonna say that if you follow Processing Foundation on Twitter or on Medium.com, we wrote a post both in English and Spanish where we show the whole process that took the whole process about this whole internationalization of p5.js, because it took a lot of years and there's a lot of people that collaborated on this, and we're super excited to be able to finally release it to the public.
Bueno, el libro se puede descargar con el modelo Paga lo que quieras. El libro está disponible y se aceptan todas las donaciones, sugiriendo una donación de $10, que es el costo del libro. Pero como la misión de Processing es acercar la programación a las personas y su misión educativa es tan potente, el libro se entrega gratis bajo una donación, es decir, está asequible para todo el mundo. Es un momento muy importante, creemos nosotros, porque al ser nosotros educadores y programadores latinoamericanos, nosotros sabemos que la programación en Latinoamérica es un espacio del conocimiento al cual no podemos acceder todos, ¿ya? Particularmente porque si no lo hacemos a través de una institución educativa formal como la universidad, difícilmente podemos aprender porque tenemos la barrera del lenguaje, ya que en Latinoamérica el inglés nos enseña a un nivel medio alto en el cual que nos permita poder aprender de manera autodidacta a programar. Por eso creemos que es un paso súper importante en la apertura de entornos de programación de código abierto como P5 o como Processing para la comunidad hispanoparlante, y es un paso cuantitativo que nos permite mirar el mundo desde otro lado. Y por eso estamos muy contentos. Como decía anteriormente, el libro está disponible en PDF, pero también en el futuro vamos a poder, o sea, va a estar disponible en Amazon para ser adquirido en su versión física.
Mhm.
La información de este proceso está disponible en el post de Medium que lanzó, ¿dónde está? El post Medium que lanzó la Fundación Processing.
That one. No.
No.
Here. No, here. Yes. So in
Claro.
So in medium.com/processing-foundation, you have two new Medium posts. One is written in Spanish and one is written in English about the whole process that for internationalization of the Processing Foundation educational materials. We talk about the process of the website and the book, and everybody was involved in this project. Yeah. That's it. That's the announcement. Thanks so much. It's an honor to be here, and we're super excited about the future of this.
Sí.
So I'll let people, if they have, you just keep the mics on.
Okay.
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 I'm just going to speak, and your mics will pick me up. It's fine. The volume's actually, people are telling me it's a little bit low, so I'm going to turn it up a little bit here. So I'll see if there's any questions in the chat. What I thought, what I would love for you guys to do is to maybe, if you could just do a brief introduction where you say your names and where you're from and how you got involved with coding and the Processing Foundation. Just so we have that also, because I think, so just to let people know, we're doing this live to make this announcement, but the same way that I often then, nobody can see me, but I'm over here. It's fine, I don't need to be, I'm on this all the time. But what we're gonna do in the same way that I sort of do a live stream and then publish edited videos later is we're gonna make this into an announcement video that will most likely be released through the Processing Foundation YouTube, which if you don't already subscribe to, you should go, I think if you just search Processing Foundation on YouTube, you'll find it. But when this video gets published, I'll make a link in the video's description also. I'll post it someone could post it in the chat, that would be great. So go subscribe to the Processing Foundation YouTube. So I wanted to just get more of an introduction from you guys that we can put at the beginning, just to have that. I think that'll be nice to have. And then I think we're gonna stay live and have do a little brief introduction to coding in P5, but only in Spanish.
Only Spanish.
So that's going to be like similar to my intro. I'm sorry that I'm only speaking English right now. That's similar to my introduction to programming videos, but they're but in Spanish, and that will figure out. Maybe I would love to have it as like a video that's on the Coding Train channel, but that might make more sense also on the Processing Foundation YouTube. We'll figure that out later. So that's what's happening. So maybe I'm gonna step aside and look at the chat a little bit to see if there are any questions. And then if you guys can just do a little more introduction about yourself, and we'll have that. And then you can go back to just have the like p5.js website,
Perfect.
the Spanish one.
Perfect.
And then we'll come back and do the tutorial. But so people in the chat who are confused, what's going on? I finished all my tutorials for today. The live stream will be archived and available later, and the edited versions will come out next week. But we're going to be here for like another half hour or so to do a bit more tutorial stuff in Spanish. So especially if you're a Spanish speaker, come join, tweet to your friends to come join. If you want to listen anyway and just kind of see what we're doing, that's great too. And of course, you can any language you want in the chat is perfectly welcome. Okay, so I'm gonna let you guys do a bit more introduction stuff.
Should we do it in English and then Spanish?
Yeah, why not? I guess so.
Okay.
We can always. So we're gonna
edit.
Mathieu, who works with Processing Foundation and with me on video editing, can put it together later. However, so we can figure out what makes the most sense. But yeah, why don't you do it? Each of you introduce yourself in, I guess, in English and Spanish.
Okay.
If that makes sense.
Let's do both in English, and then both in Spanish. Perfect. Cool. So I'm Aaron Montoya Moraga. I'm a programmer. I studied at NYU ATP, and I've been part of the Processing Foundation for some years, mostly working on this internationalization of it. I've been working on translations of the p5.js book and the p5.js website, and yeah, that's it, I guess.
Cool. I'm Guillermo Montesinos. I'm Chilean. I'm an electrical engineer, musician, programmer. Since 2 years ago, I've been working in creative coding. I started to involve in p5.js community. I've been working in the internationalization process of p5.js too. And what else? Last year I studied in the School for Poetic Computations here in New York, and now I've been accepted in ITP, so this is so cool. That's it. Yeah.
Now in Spanish, ahora en español. Hola, soy Aaron Montoya Moraga, soy programador y artista, soy parte de la comunidad de Processing, trabajo en el proyecto p5.js, estuve encargado este último año en traducir material del sitio web y del libro a español para hacerlo accesible a otras comunidades, y junto a mi amigo Guillermo tenemos un colectivo que se llama Coded, donde enseñamos introducción a programación para fines creativos en Santiago de Chile.
Yo soy Guillermo Montesinos, soy ingeniero eléctrico, soy músico, soy programador. Me he dedicado a la programación creativa desde hace 2 años, en el momento en que empecé a trabajar con p5.js, empecé a enseñar p5.js en Chile. Actualmente estoy trabajando colaborando con Aaron en este proceso de internacionalización de p5 al español. Juntos con Aaron y yo y 3 artistas más en Chile tenemos un colectivo educativo llamado Code de Escuela, en el cual intentamos empujar los entornos de programación o los software libres de código abierto y hacerlo asequible a la comunidad artística. El año pasado estudié en la School for Poetic Computation y a partir de este año voy a ser estudiante de ITP en NYU.
Gracias.
Wonderful. Okay, so one question did come. Sorry, I'll come over here. One
Yeah.
question did come in from the chat, which I'll ask. This is from Red Hen Dev. I have a Spanish student in my coding club. Is there a particular coding concept term in English that is especially difficult or strange? So I guess, to generalize that question a bit more, is like, how do you deal with variable names as you're translating examples and things like that? Are there particular considerations that you have to make when you're porting and translating things to Spanish?
Yeah, I think that sometimes there's the same word, like library, there's sometimes 2 different translations, and it's always a challenge to be consistent when we're talking. So sometimes you would use one or the other, and the people would confuse that they're actually different things, but they're the same thing. So for example, library is a concept that goes like the correct translation would be biblioteca, which is here, but library also, it's super similar to a word in Spanish that's called librería. That's why people usually translate it to. So, and they coexist. Like there's half and half of material translated both ways, and people think they're different things, but they're not.
Yeah, I think in the approach of teaching logic, like programming logic, there's no problem because it's the same mathematical logic. And I think there's no problem to use English words to explain concepts like if. This is a conditional. But in Spanish, there is other word, which is si. But I think it doesn't matter because you can use the English name for the structure, so it's okay. And in the declaration of variables or functions, I think it's okay too. It's the same idea.
Yeah, it's similar. It's like function is función.
Yeah.
But yeah, that's easy to remember. That sometimes things are more obscure, like int. It doesn't make sense in Spanish that well. And I think the biggest challenge is that there's not that much material. Like if you look up in Stack Overflow or in Google and you look for examples in Spanish, there's not that much. That's why we're excited that now all these examples on the website and the book are in Spanish, so there's a lot of material to start with.
Yeah, maybe the reference is the more important part.
Yeah.
Oh, wonderful. Okay, so I think what we're going to do now is transition to doing the Spanish language tutorial. If I'm right, this will be a total beginner tutorial. So I know a lot of people are probably currently watching. Maybe you already know programming, maybe you don't speak Spanish. So you're welcome to stay. I would encourage you to stay and watch and give us feedback. But the idea here is to take the content that we're going to show. We might as well do it live since we're here live. And I know I did just tweet it out, so hopefully a bunch of people have joined who might be new to programming, who are Spanish speakers, who are joining and watching now. Welcome, hola. That then this will get re-edited and published separately as an introduction to p5.js in Spanish for the p5.js website or wherever we end up figuring out to put it. So that I'll let you guys figure out what you want to do. So and so you can it's a sort of silly thing that I do when I do this video stuff is like this whole thing is happening live, but then I think to myself, okay, now this new thing is beginning. Start it that way. All right?
Okay.
So
Perfect.
okay, great.
So we're gonna be in Spanish in 3, 2, 1, go.
Listo.
Hola, con Guillermo.
Actually, time out. I forgot.
Oh.
Something that's useful to do, just because sometimes you'll be standing in front of stuff, is that what I'm going to do is I'm going to do a screen capture also. Sorry.
Oh, okay.
This is very normal, all this like live production stuff that normally would not be live streamed. So if we do new screen recording, because this is also just a good backup to have. And I think now it is recording.
It is recording.
So just because one of the things you'll notice is where you're standing is often might be in front of something you're showing,
Okay.
which is fine.
Mhm.
And that way, when we edit this later, it'll get sort of
Okay.
cross-faded in and out.
Mhm.
But if you keep this mostly like kind of over here, I mean, you might need more room than that. So, but and then
Yeah.
if you the further you guys are over this way, the less you'll be.
Oh, okay.
Yeah. It's
Cool.
it's backwards.
Ah,
Okay,
okay.
sorry. Now you can do your 3, 2, 1.
3, 2, 1, Spanish. Hola, vamos a hacer un tutorial hoy día. Mi nombre es Aarón
Mi nombre es Guillermo Montesinos.
y vamos a empezar a usar p5.js, p5.js, que es una biblioteca de JavaScript que nos permite hacer páginas web interactivas y programación creativa. Vamos a asumir que es primera vez que entramos a este sitio y que no sabemos casi nada. ¿Sí?
Solo hacer clic.
Sí. Entonces, veamos. Entramos a la página p5js,
Sí.
p5js.org. Aquí arriba están los botones para cambiar de idioma. Desde hoy día está disponible en español. Y vamos a descargar p5. ¿Ya? Entonces, en descargar, podemos descargar esta versión completa de la biblioteca. Y cuando se descarga, la descomprimimos y encontramos estos archivos.
Que son archivos JavaScript.
Claro.
Estaba pensando en qué estarán pensando los amigos latinoamericanos
¿Ya?
y españoles no chilenos según por nuestra forma de hablar.
Ah, somos chilenos.
Somos chilenos. Y
Entonces-
eso es grave. No es grave, pero es complejo.
Vamos a
tratar de
tratar
hablar como Disney.
Sí, vamos a tratar de hablar lo más neutralmente y lentamente posible.
Sí.
Estamos un poco nerviosos, pero
Estamos bien.
vamos a hacer nuestro mejor esfuerzo en hablar claramente y no tan rápido.
Sí.
Estamos leyendo igualmente los comentarios acá al lado. Acá al lado podemos ver los comentarios que nos dan. Entonces, retomando, nos metemos a la página de P5, p5js.org. Está disponible en español, p5js.org/es. Y en descargar podemos descargar la biblioteca. Entonces hacemos clic acá, se descarga y después de descomprimir ese archivo tenemos estas 4 cosas. Tenemos la biblioteca p5.js, que es un archivo en JavaScript, que adentro contiene todo lo que P5 es capaz de hacer. Nosotros solamente lo vamos a usar, no lo vamos a leer. Son muchas líneas de código. Está la versión min, que es una versión minimizada, más liviana para cargar. Tenemos otras bibliotecas como P5DOM, P5 Sound, que son adicionales. Y tenemos este empty example. Empty example significa ejemplo vacío. Vamos a usar esta parte.
Claro. Porque como ustedes pueden ver en los primeros tutoriales de Dan, P5 es una biblioteca de JavaScript y JavaScript es un lenguaje que corre, es un script que corre sobre HTML. HTML es el entorno en el que se programan las páginas web. Y si pudiéramos hacer un paralelo entre el mundo real, podríamos decir que HTML es similar a un periódico, una hoja de periódico, que básicamente no cambia con el tiempo, o cambia muy poco, es más estática.
Claro, HTML te permite escribir esto es un título, esto es un párrafo, y eso se parece mucho.
I forgot about this. I meant to restart this. So you could just back off like a sentence or
Okay.
two.
Hi again. Entonces, claro, como decía Guillermo, HTML es un entorno de programación que te permite escribir páginas estáticas. Entonces, una página HTML es como un periódico, un diario, que tiene un título, tiene un párrafo, tiene una foto, tiene un encabezado, una bajada, tiene links a otras partes. Eso es HTML, te permite decir, este texto es esta cosa.
Claro.
Y así se construyen las páginas web, con HTML.
Exacto. Y a partir de HTML5 existe la posibilidad de incrustar JavaScript, que son lenguajes de programación que van cambiando en el tiempo, y que permite la posibilidad de crear el canvas, que es un cuadro o un lienzo, la traducción literal de canvas es lienzo, en el cual podemos pintar o dibujar o hacer cosas animadas. Entonces, sobre una página HTML nosotros corremos un script JavaScript que cambia en el tiempo, y en particular nosotros vamos a ocupar la biblioteca p5.js, que es un set de muchas funciones y variables. Como preguntó alguien, como comentó alguien, una función en programación es un set o un grupo de muchas líneas de código o muchas operaciones que van haciendo tareas particulares. Entonces, si yo tengo, por ejemplo, si yo creo una función que sea mover teclado, que tengo acá, yo tengo un teclado, la función mover teclado requiere ciertos pasos, como por ejemplo, acercarme hacia el teclado, girar a la derecha, tomar el teclado y traerlo hacia acá, dejar el teclado. Eso es una función, es un set de operaciones lógicas que permiten cumplir cierta tarea.
Claro, entonces P5 también es una biblioteca que nos permite que una página web sepa dónde está el ratón, dónde está el mouse, sepa si es que hemos presionado una tecla, y nos permite hacer que esto modifique el comportamiento de la página web. Podemos cambiar los colores, podemos hacer muchas cosas. Entonces HTML5 tiene un elemento que se llama canvas, que es un lienzo. Entonces la página que vamos a abrir hoy día, si vemos el archivo, veamos el archivo, vamos a usar hoy día un editor de texto que se llama Atom. Vamos a aumentar el tamaño. ¿Cómo aumento el tamaño con esto? Claro, entonces si ven, este es un documento HTML que dice, tiene un cuerpo, un body y tiene padding 0, margin 0. Significa que le quita todo tipo de, ¿cómo se llama padding en español? Como de marco. O sea, uno puede enmarcar la página con un cierto borde, le quita los bordes y después lo que hace es que ejecuta esto que se llama script y abre p5 y abre p5, abre otras cosas de p5 y al final, después de hacer todas esas cosas, que es cargar esta biblioteca, ejecuta sketch.js, que es el archivo que está inmediatamente acá al lado, que es este. Abrámoslo con Atom también. Ups, abrámoslo con Atom. Y que está acá, que no tiene nada. Esto es lo que, así partimos un proyecto en blanco en P5. Entonces nos va a permitir tener un lienzo, un canvas, que es un elemento en HTML, va a estar en la pantalla y vamos a hacer cosas en él.
Exacto. La biblioteca de P5.js tiene dos funciones estructurales, podríamos decir. La primera es la función setup y la segunda es la función draw.
Que setup significa configuración,
Claro.
que es como el paso inicial, y draw significa dibujar, porque
Sí.
vamos a partir haciendo una aplicación gráfica, que es como nació P5.
Claro. Sí, antes de eso quería decir que la programación, en la programación, la máquina, lo que nosotros hacemos es darle órdenes a la máquina para que ejecute ciertas tareas, ¿cierto? Y la máquina es occidental, porque se inventó acá. Entonces lee de izquierda a derecha y de arriba a abajo. ¿Eso qué significa? Que las cosas que yo ponga primero se ejecutan o se adquieren o se definen primero, y las cosas que están más abajo se van definiendo o van modificando las operaciones que yo fui haciendo antes. Entonces, P5 tiene esta estructura que es función setup y después función draw, que es muy similar al Arduino. Para los que han trabajado con Arduino pero no han programado con P5 o con Processing, Arduino tiene una función setup, un void, y luego tiene un void loop. Ese void loop lo que hace es ejecutarse muchas veces en el tiempo, infinitas veces, según una frecuencia que la define en particular el integrado, en este caso, pero que lo que permite es agregar la variable de tiempo a nuestra lógica. Entonces, en P5 tenemos setup y tenemos draw, y draw es un paralelo del loop. En el caso de P5 y de processing, draw se ejecuta a una frecuencia de 60 veces por segundo, como máximo, en el mejor de los casos. Y va a irse acotando según la eficiencia de la máquina, según lo que le exijamos.
Claro, o sea, si es que no hacemos nada, no especificamos ni una cosa acá, hacemos clic, esta página corre, hace setup, que no hay nada, lo hace una vez, después entra draw y lo ejecuta un máximo de 60 veces por segundo. Eso lo hace si es que no hacemos nada. Podemos bajar esta velocidad y podemos subirla, pero esto siempre va a ser el máximo. Si nosotros decimos 60 veces por segundo, significa que va a ser, en el mejor de los casos, 60 veces por segundo, y si tratamos de que, si es que hacemos por ejemplo una función que es muy difícil de hacer, que se demora mucho, va a hacerlo más lento. Pero nosotros siempre podemos ser capaces de ejecutar, de definir la velocidad máxima de operación de esto. Y como son 60 veces por segundo, nos permite ver que una página, nos permite animar una página. Entonces creemos nuestro primer proyecto en P5
Claro.
y para esto vamos a crear primero un lienzo donde dibujar. Entonces hay una función que se llama createCanvas, que significa crear lienzo. Las mayúsculas importan, entonces esta función tiene que ser create todo con minúscula y canvas con mayúscula. Ahora, ¿cómo sabemos que esto existe? Porque en la página de P5, y esta es la gracia, es que en la página de P5 está la referencia donde están todas las funciones que tiene P5, todas las variables, todo lo que podemos usar. Entonces, createCanvas es una función que aquí hay un ejemplo que funciona y nos dice qué es lo que hace. Entonces, lo que hace createCanvas es que le damos dos parámetros, escribimos dos números adentro de la función. Entonces, esta función tiene paréntesis y adentro vamos a poner dos números separados por una coma. El primero va a ser el ancho del lienzo y el segundo el alto del lienzo. Y todo esto va a estar en la parte de más arriba de la página, en la esquina superior izquierda. Entonces hacemos 100%, vamos a tener un lienzo y para eso podemos abrir este archivo index.html que ejecuta P5 y ejecuta nuestro sketch. Podemos abrirlo con Chrome o con cualquier navegador y aquí tenemos un lienzo que no se ve porque tenemos que definir qué color es el lienzo. Entonces después de crear el lienzo, como dijo Guillermo que esto va en orden, vamos a decir, por ejemplo, background, que significa fondo, ¿ya? Y le podemos dar, por ejemplo, tres parámetros. Que el típico modelo en color que es RGB, que es red, green, blue, que significa rojo, verde y azul, que es cuán rojo, cuán verde y cuán azul, y son números que van entre 0, el mínimo, y 255. Démosle 0, y eso va a ser nada de rojo, nada de verde, nada de azul, y va a ser un lienzo negro. Si actualizamos esta página, vemos acá un lienzo negro de 100 píxeles por 100 píxeles.
Algo importante que rompe la lógica de los planos cartesianos o vectorial que ahora le enseñan en la enseñanza básica o primaria, dependiendo de cómo se dice en cada país, es que el canvas es un plano en dos dimensiones, por lo tanto tiene un eje X horizontal y un eje Y vertical. Pero la diferencia de la matemática tradicional es que el eje Y, que representa el alto, no crece hacia arriba, sino que crece hacia abajo.
Entonces el punto 00, el origen de este sistema, está ahí. Está en la esquina superior izquierda del navegador y X crece hacia la derecha e Y crece hacia abajo.
Entonces nosotros podemos hacer, por ejemplo, que este canvas sea más grande, para que se note mejor en su pantalla, y darle un parámetro de color gris. ¿Por qué hice esto? Recién Aarón cuando definió el color escribió 000 porque había que asignarle 0 a rojo, 0 a verde y 0 a azul. Pero la función background y las funciones de color en general de P5 entienden que si yo le doy solo un parámetro, ese parámetro corresponde al brillo, es decir, al color en escala de grises, y que también va de 0 a 255. Básicamente esto significaría que el promedio entre el R, el G y el B es 200.
Y son todos iguales. Entonces ahora, por ejemplo, otra cosa fantástica de P5 es que en este momento esto es un lienzo que nunca cambia, ¿no es cierto? Y claro, de repente puede ser que nosotros sabemos que este lienzo queremos que sea pantalla completa. Nosotros queremos programar a pantalla completa. Y P5 cuando se abre, o sea, P5 cuando se ejecuta, siempre sabe cuánto mide la ventana del navegador y la podemos usar. Entonces eso es una variable que p5 siempre la está actualizando. Siempre actualiza todos estos píxeles mide hacia la izquierda, o sea, todos estos píxeles de ancho y de alto. Entonces podemos decirle window, que significa ventana, ancho, que significa, o sea, width, que significa ancho. Y lo mismo para la altura, existe window height, la altura de la ventana. Y cuando grabamos esto, ahora el lienzo va a estar a pantalla completa. Y eso es fantástico porque nos permite usar toda la página web como recurso. Ahora, el drama de esto es que si, por ejemplo, achicamos esto y lo actualizamos, se crea el lienzo y si cambiamos el lienzo, si hacemos que el navegador cambie, no se actualiza. p5 también pensó en eso Y si vemos la referencia y buscamos cosas que digan window, que sean como la ventana, hay una función acá. Las funciones son aquellas que tienen paréntesis. Una variable es un nombre y las funciones son un nombre con paréntesis. Entonces esto es una función que hace algo, como dijo Guillermo. Entonces aquí ven, dicen function window resize, función hacer el tamaño del window. Si no saben lo que pasa, bueno, aquí está explicado. Cada vez que la ventana P5 sabe que el navegador cambió de tamaño, hace algo. ¿Y qué hace? Hay una función que se llama resize canvas, que es cambiar el tamaño del lienzo. Entonces, copiemos y peguemos esto, porque este código funciona y esa es la gracia también. Lo vamos a pegar a continuación de lo que ya estaba. Y ahora el lienzo, cada vez que lo cambiamos de tamaño, crece con... Ups, bueno, lo hizo, pero lo único que hizo fue cambiar el lienzo, pero no sabe qué color es. Copiemos el color aquí, entonces va a hacer el lienzo nuevo, que por defecto es blanco, y lo va a pintar gris. Tenemos que actualizar. Y ahí está. Ahora tenemos un lienzo que siempre está cambiando. Si lo hacemos rápido, alcanzamos a ver que, no sé si lo pueden ver, que es blanco el borde, pero es que se va creciendo.
Sí, algo interesante o importante, respondiendo a algunas preguntas también, que nos dicen ya y las palabras claves, o la sintaxis. La sintaxis en programación es muy importante. En JavaScript es un poco más laxa, porque JavaScript es como permite hacer algunas cosas sin ser tan formal como otro lenguaje, pero sí es muy importante decir que las funciones, al ser llamadas, siempre llevan un paréntesis, como por ejemplo la función setup. Entonces, cuando nosotros vemos una palabra con un paréntesis al lado, el paréntesis puede llevar valores dentro o puede no llevar, podemos inmediatamente entender que esa es una función. Cuando usamos palabras solas, estamos hablando de una variable, ¿ya? Ahora, es importante en JavaScript utilizar el punto y coma, o el semicolon. En la función del punto y coma es indicarle a la máquina que estamos terminando una línea de código. Es poder separar, es poder ordenar la información. Pero en este sentido yo, cuando les mencionaba recién que JavaScript es un poco laxo, nosotros podríamos escribir esta línea sin punto y coma y funcionaría igual, ¿ya? Pero por una cuestión de orden, una cuestión de pulcritud en la programación, pensando que cuando programamos también van a haber otras personas que van a trabajar con nuestro código, es importante en realidad mantener el orden y utilizar los comentarios. ¿Qué son los comentarios? Los comentarios son estas líneas que en mi código aparecen en gris y que son frases o palabras que tienen dos slash al lado izquierdo que le indican a la máquina todo lo que está a tu derecha no lo leas, ¿ya? Y se utiliza como comentarios para el programador. Eso.
Exacto. Entonces, todo el código que venga después de estas dos barras, la máquina lo omite. Son para que nosotros como programadores sepamos, por ejemplo, qué está pasando. Aquí dice poner código de setup aquí, ¿no es cierto? Aquí, por ejemplo, podemos escribir, esto es súper bueno en modales, es decir, background 200, esto es hacer que el fondo del lienzo sea gris. Y después realmente lo hacemos. Entonces ahora, ¿qué creo que está pasando? Se abre la página web, se hace setup una vez, se crea el lienzo, se pone de color gris y después entramos a draw. Draw dibuja 60 veces por segundo y en este momento no está pasando nada. Hagamos algo. Vamos a poner una elipse en el lienzo.
Para eso vamos a llamar la función elipse.
Que está en inglés, entonces con doble.
Claro. La función elipse, si vamos a la referencia de P5, es una función que recibe 4 parámetros. Un X, un Y, un W y un H. ¿Qué significa esto? El X y el Y corresponden a la coordenada en la cual se centra la elipse, ¿ya? Mientras que el W y el H corresponden al largo de los focos de la elipse. Una elipse tiene dos focos, por lo tanto puede no ser un círculo, puede tener un largo hacia horizontal y un largo vertical. Por eso es W de width y H de height. Entonces, si nosotros queremos dibujar una elipse en el píxel 100x, 100y, que tenga 50 píxeles horizontales y 50 píxeles verticales, llamamos la función de esta manera, actualizamos y tenemos una elipse
Claro, entonces ahora el setup se ejecutó una vez, se creó el lienzo, se pintó gris y ahora 60 veces por segundo se está dibujando una elipse en el píxel 100,100 de 50 de ancho y 50 de alto, por lo tanto un círculo, porque es el mismo ancho y alto, pero esto se está haciendo siempre lo mismo. Entonces P5 también tiene funciones, tiene variables, que por ejemplo sabe dónde está el ratón, el mouse en la pantalla, y vamos a reemplazar ahora X e Y para mostrarles que podemos hacer ahora una animación. Entonces, si decimos mouse X y las mayúsculas importan, tiene que ser mouse con minúscula y X con mayúscula, lo mismo con mouse Y. Y ahora si lo grabamos y actualizamos esto, ahora ven que cada vez que el mouse se mueve, o sea, por cada cuadro, donde sea que esté el mouse, se pone una nueva elipse en la pantalla. Y de hecho vemos el trazo.
Ahora, ¿por qué estamos viendo el trazo? En este caso es porque el fondo se pinta una pura vez. Si nosotros pintáramos el fondo en cada ciclo draw,
Y el orden importa. Primero vamos a pintar el fondo gris en draw y después sobre eso vamos a poner la elipse.
exacto,
Y grabamos.
vamos a ver que la elipse se mueve siguiendo al mouse.
¿Qué pasa si lo damos vuelta?
¿Qué pasa si lo damos?
Si lo damos vuelta va a cambiar. Veámoslo. Primero se va a pintar la elipse sobre eso el fondo y no la vemos, pero se está pasando por detrás. Pero sobre todo eso al final se pone el fondo gris. Entonces no lo vemos.
Exacto.
Ahora P5 pintó esta elipse de una cierta manera, la pintó con un borde que tiene un píxel de ancho, la pintó de un color negro el borde y adentro la pintó blanca. ¿Por qué? Porque ese es el color por defecto. O sea, si no le decimos nada a P5, va a hacer eso. Pero somos capaces de cambiar esos tres parámetros. El ancho del borde, el color del borde y el color del relleno de la figura. Entonces acá ahora, si ustedes ven, quizá no se ve mucho, pero stroke significa trazo, y ahora el trazo es rojo, porque tiene 255, el máximo de rojo, G y B están en 0, por lo tanto es solamente rojo. La otra función importante es stroke weight, que es cuán ancho es el borde y se mide en píxeles. Entonces el borde va a ser mucho más grande, va a ser de 10 píxeles. Al actualizar esto ven ahora que el borde de la figura tiene 10 píxeles de ancho y es rojo. Hay otra función también para cambiar el relleno de la elipse, que se llama fill, de relleno.
¿Y qué la pintamos?
Hagámosla azul.
Como la U.
Claro. Ahí. Y ahí está. Bien. Hay otras funciones súper interesantes que ustedes ven y hay gente que le encanta esto por un rato y juega a alcanzar el ratón con la elipse. De repente, ¿qué pasa si no quieren ver la elipse? Hay funciones para eso. La vamos a mostrar súper corto. Hay una función que la vamos a poner en setup. ¿Por qué? Porque vamos a decirle, la configuración de este software va a ser que el cursor no se vea. Hay una función que se llama noCursor que hace que no se vea el mouse. Si actualizamos esto, ahora el mouse está invisible, no se ve, no hay ratón. La vamos a comentar, vamos a ponerle esta doble barra para que se vuelva a ver el ratón, para que nos ubiquemos. Y vamos a, por ejemplo, mostrarle ahora la función también de aleatoriedad. Hay una función súper importante que se llama random, que hace que las cosas sean aleatorias, para que no siempre sean iguales.
Claro.
Entonces cambiemos el color
El relleno.
del fill. Entonces en vez de ser 00255, vamos a decir uno de esos parámetros, esta función, adentro de meter un número estático que siempre es el mismo, como 0, dice random 255. Entonces ahora esta función va a arrojar un número entre 0 y 255 por cada vez que se ejecute el cuadro.
Exacto.
Entonces esto va a ser súper rápido.
¿Qué pasa?
Entonces, ven, en cada cuadro hay un color distinto. De hecho, está cambiando cuán rojo es.
Exacto.
Hagamos que el color entero sea aleatorio. Vamos a usar los tres parámetros aleatorios. Random 255, random 255 y random 255 en el fill de la elipse. Y ahora esta elipse en cada cuadro tiene un color distinto. Y esto es súper rápido, es muy rápido. Y podemos también alterar la velocidad de cada cuánto se actualizan los cuadros de P5.
Exacto.
Entonces,
para eso utilizamos la función framerate.
Que significa, frame significa cuadro y rate significa tasa con S de cambio.
Claro. A través de la cual podemos fijar la velocidad de refresco de los cuadros. Podemos decir, por ejemplo, 20 cuadros por segundo.
Que es un tercio de la velocidad.
Podemos ver que las transiciones son mucho más lentas.
Pon 1. frame rate 1, y una vez por segundo se va a actualizar. De hecho, una vez por segundo va a seguir al mouse y va a cambiar un color. Esto hace que sea mucho más lento.
No como hablamos nosotros.
Claro, nosotros estamos hablando rápido, estamos un poco nerviosos todavía.
Estamos hablando en chileno.
Estamos un poquito emocionados de estar acá.
Ahora,
sí,
podemos hacer que aparezcan
sí,
muchos círculos. Por ejemplo.
claro. Creemos una variable, creemos la variable cuántas.
¿Ya?
¿Ya? Entonces vamos a crear una variable. Esto lo hacemos afuera de function, afuera de draw. Setup, o sea, la función setup empieza donde empieza esta llave y termina donde termina esta llave, ¿no es cierto? Todo lo que está dentro de estas dos llaves es la función setup, todo lo que está dentro de la función draw es la función draw y todo lo que está dentro de la función window resize, ¿no es cierto? Esas llaves delimitan donde empiezan y parten las funciones y todo lo que está fuera de eso está a un nivel global. Entonces vamos a crear variables nuestras, así como mouse X y mouse Y son variables,
Exacto.
que P5 se encarga de preguntarle al navegador cuánto valen, dónde está el ratón, nosotros podemos hacer variables. Entonces ahora aquí Guillermo hizo una variable que se llama número figura y que vale 1000. La manera de hacer una variable, hay varias maneras, pero una es decir let, número figura.
Var, por ejemplo.
También var, que es una manera más antigua de hacerlo.
Claro.
Vamos a usar la manera más moderna que es let hoy día. Y ahora, número figura vale 1000 y día max vale 100. Entonces las podemos usar ahora en nuestro código.
Claro. Un poco de contexto, una variable, suena raro que es una variable. Podemos hacer el paralelo con las variables cuando aprendimos ecuaciones en el colegio y teníamos una fórmula que decía x más 1 es igual a 20. ¿Cuánto vale x? Bueno, algo similar pasa acá. Las variables son espacios virtuales donde se asignan valores. Pero esos espacios virtuales en realidad apuntan a un espacio físico del disco duro de nuestro computador. Entonces la variable se declara y luego se asigna. Es decir, hay un proceso doble, proceso dual que estamos haciendo en esta línea, que es primero declarar la variable, es decirle al computador, existe una variable o crea una variable que en este caso se llame día max. Y el computador reserva un espacio dentro del disco duro donde va a guardar todo lo que yo le diga que ponga en día max. Y luego le digo, computador, en día max asigna un número igual a 100. Entonces le digo día max igual a 100. Esta línea simple son dos procesos y son dos procesos súper importantes y que es importante entenderlos por separado, porque la variable en sí mismo no existe hasta que yo la declaro y luego no tiene valor hasta que yo le asigno el valor. El valor de una variable se puede asignar todas las veces que yo quiera y lo puedo ir modificando utilizando el signo igual, que es un operador, que es el operador de asignación. En programación el signo igual no funciona como igualdad, como operador lógico de similitud, sino que funciona como un operador de asignación. Ahora, las variables pueden tener distintos contenidos, distintos tipos de información. Pueden tener números, pueden ser enteros o pueden ser decimales. Pueden tener letras, que pueden ser caracteres o cadenas, strings, o pueden ser valores lógicos, que son las conocidas variables booleanas, que tienen dos estados, 0 o 1, que en realidad se interpretan como verdadero o falso.
Exacto.
Eso,
sí.
Respecto a la variable.
Entonces, las variables son elementos en la memoria que les podemos dar un nombre y un valor. Y como puede ser cualquier nombre, la idea es que siempre pongamos un nombre que tenga algún sentido. Como ahora tenemos una figura que se llama elipse y vamos a hacer varias de ellas. ¿Cuántas vamos a hacer? Vamos a hacer 1000. Entonces, las ponemos inventamos una variable que se llama número figura y le asignamos el valor 1000 para después en el resto del código usarla. Por ejemplo, ahora el diámetro máximo, que le pusimos día max para no hacerlo tan largo, vale 100. Entonces ahora en la elipse podemos, en vez de decir 100, podemos decir día max. Entonces eso va a ir cuando se ejecute la función la elipse, va a ir al computador y preguntarle cuánto vale mouse X, cuánto vale mouse Y, cuánto vale día max. Y si ven es lo mismo. La gracia es que este valor puede estar en muchas partes, puede haber muchas elipses o cosas que dependan de ese valor y en un lugar del código, que es ahí, ¿no es cierto? Podemos cambiarlo a 200 y eso hace que en todas las partes donde el computador le pregunta, cuánto vale día max, se actualiza. Y eso hace que el código sea mucho más modular y que hayan variables e información que dependa de otra. Perfecto. Entonces ahora vamos a hacer muchas elipses.
¿Cómo hacemos muchas elipses? tenemos una forma que es la más simple, que es copiar la línea que dice elipse muchas veces y modificarle los valores. O sea, si queremos que la primera esté en 0, 0, que la segunda esté en
100, 100.
en 100,100, pero esto no lo vamos a hacer porque si no nos van a echar de este canal de YouTube
Y la vía es muy corta.
y la vida es muy corta.
Sí.
Entonces,
Hazlo, a ver,
ya, bueno, hagamos.
graba.
Ya.
Entonces por cada nueva línea va a crearse una nueva y podríamos hacer que se genere en una posición aleatoria, muchas cosas,
Claro.
pero obviamente es muy tedioso si queremos hacer 1000, o sea, si incluso queremos hacer 10,
Es muy tedioso.
es muy tedioso.
Y muy
Entonces,
poco eficiente también.
sí.
Entonces, para eso existe...
En programación, esto no tiene que ver con P5, esta es la manera en JavaScript, este es el lenguaje de programación sobre el que se construye P5, hay una manera para repetir cosas, que se llama for, es un bucle que se repite muchas veces. Entonces, ¿qué es lo que hacemos? Escribimos i igual 0, creamos una variable, chida, ponle, sí. Escribimos una variable que se llame i igual 0, entonces es un contador, va a decir 0. Después hacemos una condición, que es, mientras i sea menor que un número figura, ejecuta esto. Entonces, el computador corre todo el código, llega al for, que es este bucle que se repite, y dice ya, la primera vez que lo hace, cuando llega ahí, crea una variable que se llame i, y vale 0. I vale 0. Después dice, ejecuta todo lo que está dentro de for, adentro de estas llaves, mientras i sea menor que número figura. Número figura en nuestro caso vale 1000, y i vale 0, por lo tanto se va a ejecutar. Y va a decir, elipse, 0, 0, diamax, diamax. Pongámosle un random. Pongámosle que se ponga en cualquier parte de la pantalla. Podemos decir random de 0 al ancho de la pantalla, que es la variable width, y de 0 a la altura de la pantalla, que es random height. Entonces, cada vez que se ejecute esta línea de ellipse, va a crearse una elipse en cualquier parte de la pantalla del diámetro que nosotros especificamos. Ahora, si es que,
diámetro.
¿qué pasa? I vale 0, y es positivo, es verdad que i es menor que un número figura, que vale 1000, entonces 0 es menor que 1000, ¿verdad? Lo ejecuta, lo ejecuta, lo ejecuta, y esto podría ser un bucle que se repita hasta el infinito. Como eso echaría a perder el computador, no es eficiente, la idea es que el código siga. La tercera condición que ven ahí, que es la más corta, dice i más más. Significa que una vez después de ejecutar el for, hace que i se incremente en 1. Entonces la primera vez que se ejecute va a valer 0, después va a valer 1, va a valer 2, va a valer 3, y así hasta que haya un momento que va a valer 1000 y va a preguntar, ¿vale 1000 menor que, es 1000 menor que el número de figura que vale 1000? La respuesta es no, porque 1000 no es menor que 1000, son iguales. Y se termina de ejecutar el for y sigue adelante, pero eso después de haber hecho 1000 veces esta línea que está dentro del for loop. Y podemos escribir muchas líneas adentro del for loop. Veamos cómo se ve esto. Ahí hay 1000.
Muy psicodélico.
Hay 1000 elipses, una sobre otra, en posición aleatoria en la pantalla, con una línea de código adicional, que es tomar esta elipse y ponerla dentro de un for.
Sí, mucho.
Podemos... hagamos que el diámetro también sea aleatorio.
Sí.
Entonces el diámetro es, en vez de hacer que solamente sea siempre el mismo diámetro, vamos a hacer random diamax, que va a ser random, un número aleatorio entre 0 y ese diámetro mayor. Y 0 lo ejecutamos. Ahora todas tienen un número aleatorio en su diámetro, incluso hay algunas que el ancho y el alto son distintos.
Sí. Eso.
Yo creo que eso es lo que queríamos mostrarle hoy día. Esto es un ejemplo básico, usando una elipse, mostrándole las cosas que se pueden hacer con color, cómo funciona el setup y el draw, las funciones adicionales que tiene P5 para, por ejemplo, saber cuando el lienzo, el navegador, se agranda, se achica. Hay maneras, por ejemplo, para P5 para acceder a la cámara web de tu computador, para saber cuando uno hace clic. Hay maneras de decir si es que son menos de las 4 de la tarde, haz esto, si es que son más de las 4 de la tarde, esto. Y se pueden hacer muchas páginas web muy bonitas que son interactivas. Para cerrar les queremos mostrar unas pocas...
Sí.
We're finishing. We're almost done.
Perfect.
We're good in time, right?
Yeah, you're
Cool.
Nos están echando.
So, inglés, español. La semana... Tú dilo.
Sí, bueno, nosotros comentamos al comienzo con Aarón de que nosotros tenemos una escuela. Fundamos una escuela en Chile con Natalia Cabrera, Camila Colucci, Cristian Oyarzún, otros artistas y programadores chilenos, que se llama codeescuela.cl. En Code de Escuela nosotros desarrollamos clases, o sea, desarrollamos material en español para aprender lenguajes de programación creativa, en particular P5, pero también Python, y liberamos el curso introductorio de P5.js, que está en español y cuyas clases están disponibles, están abiertas porque son de código abierto. Y
Aquí les enseñamos desde cero, qué es una variable, qué es una función, cómo hacer un for loop.
claro,
Todo esto lo hacemos en español, en clase, y lo pueden acceder a nuestra página. Estamos siempre cambiándola y mejorando los contenidos.
exacto.
Y empezamos con un taller corto de 4 horas, hace 2 años, y hoy día ya tenemos un taller que dura 6 sesiones, y cada una de 2 a 3 horas, y en la cual los alumnos hacen un proyecto final. Entonces, tú acabas de dictar ahora en marzo.
Sí, en Santiago de Chile dictamos bueno, lo dicté yo,
¿Sí?
el curso de Introducción a la Programación Creativa usando P5, un curso que duró 6 clases, en las cuales vimos las primeras 4 utilizamos para revisar contenido, y las últimas 2 clases las utilizamos para desarrollar un proyecto. Asistieron personas que no sabían programar, hicieron cosas tan interesantes como un perro que hace ejercicio para poder comerse sus nuggets, por ejemplo, que la hizo Alexandra Hyland, que es una cineasta que trabajó las narrativas con estética de pixel, o un estudiante que nunca había trabajado en la estética, sino que viene del ámbito de la programación y quiso hacer un cover de la portada del disco AM de Arctic Monkeys, o un artista visual que trabaja en video mapping y hizo un proyecto pensando en que pudiera ser utilizado para proyectarse en visuales de una banda musical.
Ujú.
O las animaciones de Sebastián, que son...
Esta responde a ruido, entonces cuando aplaudimos, cambia. Entonces P5 es capaz de acceder al micrófono y saber qué frecuencias están pasando, cuál es el volumen de lo que está pasando. Y todos estos son proyectos que se hicieron en 3 semanas de que duró este curso. Y estamos muy contentos que ahora haya más material para que todo el mundo pueda acceder a estas cosas. Así que gracias por tenernos acá.
Sí.
Thanks for everything. Yeah, that's a wrap up. Yeah, thanks.
Gracias.
All right.
Thank you.
Gracias. Thank you so much. Oh, look, and this is responding to me.
Yeah, sure.
Okay, so this wraps up the live stream for today. Actually, I do have a really ridiculous request that I'm like pretending to blame it on the chat.
Okay.
But during my live streams, as a sort of tradition, I will sometimes read random numbers.
Okay.
And so I thought maybe you might like to read a few random
Sure.
numbers in Spanish.
Sure.
So hold on. So I'm gonna. This will take us out. Actually, I'll let you do it. Then I'll say goodbye.
Okay.
I don't know what this is ever going to be used for. So you could each just read one line. I don't know. Sometimes I play some lullaby music. It's nice to have
This
this
is
in
so
the
fun.
background. Okay.
Okay.
Bueno, este es el libro con números aleatorios. Se llama Random Digits. Y en español, in Spanish, it sounds like this. 13.750, 15.977, 94.897, 21.249, 4.491.
Y sigue así. 50774, 63004, 43062, 26312, 37949, 38580.
Wonderful. Okay, so you guys can stay here. So I'm going to do this awkward thing where the only way to end a live stream is just come over here and click a button. So I'll do that in a minute. But I want to just make a couple announcements, which is that one. So this live stream of the whole time with Aaron and Guillermo here will be archived, as long as YouTube exists. So that will be there. And once this, later tonight or sometime this weekend, the description for the archived version of the live stream will include links to everything about the Spanish P5.js, the book, their websites, and all of their work. So should be, and the Medium post and all of that. The other thing that I hope that we'll do, so in addition to the Neuroevolution tutorials that I did earlier today, those will come out next week on the Coding Train YouTube channel. The announcement about the Spanish P5.js and the Spanish P5.js and this P5.js tutorial we will make into a separate standalone video. One thing that I think would be great to do, I'm trying to do better this with my own content, is to make sure everything is captioned to make the videos as accessible as possible. So if anyone is out there wants to volunteer to help caption in Spanish or even translate into English, so we could have the Spanish tutorial have English captions, please feel free to get in touch, like write a comment. YouTube has some features where people can actually just submit those. So also subscribe to the Processing Foundation YouTube channel, where I hope that a lot of this content will be available or cross-posted. I don't know the best way of doing that. Is there anything really important that I said that you should translate into Spanish? Subscribe to the, so tell people in Spanish to subscribe to the Processing Foundation YouTube in case that's where we end up posting the Spanish language tutorial.
Dale.
No me sé la dirección.
Busquen Processing Foundation en YouTube. Vamos a ver el link acá.
Yeah.
Processing Foundation. Búsquenlo en YouTube y el primer resultado, suscríbanse porque este video va a estar puesto en los dos canales, tanto en Coding Train como en Processing Foundation.
And just as an aside, I believe if I go here to Community Day,
We are there.
we will find
Yeah.
There.
yeah, right here.
Yeah.
So you can watch, if you haven't watched the Processing Community Day videos, here they are. So thank you everybody for tuning in. Thank you for all the support in the chat. People were all of a sudden commenting in all sorts of other languages.
Yeah.
And I think it's really wonderful and exciting to me that we're finally able to do this. It's such a complicated technical thing on the one hand, but also just I know you guys have put in so much work into all the translations and everything. So that's I'm really excited and thrilled that it's out there. You can leave comments on YouTube. You can tweet at processing.org is on Twitter. p5.js is the p5 Twitter account. These guys are also on Twitter.
Yeah.
So all the information for all that will be in the video description. All right, so next live stream will not be next Friday. I have a thing here at ITP all day next Friday, so hopefully we'll pick another day next week to do a live stream. Otherwise, I'll probably do a makeup the week after. I'm trying to do it once a week. That's my plan. Okay. Oops. So goodbye. I'm going to just press stop streaming, stop recording, and I'll see you all next time.